All right, let's continue. Hello, hello. I thought today I was. I think I wanna continue a little bit with the code generation actually, because I was thinking on what to do, and we did the animations code generation last time. So basically, we have a bunch of JSON files with animations defined in them. And we take the data, and produce generated code for all the different animations that we have, so that we get, compilation safety, type safety, auto completion, and all that good stuff for this thing. Now, I was thinking like, well, it should be easy to do this for entity types as well, or I say easy, but really, I think that would give us a lot as well, because right now, if you go to how the entity types are done, first you have to go into this file and add the entity type here, what it's named. Then what you need to do is you need to update a whole bunch of places. So basically, yeah. So we have you need to define if you have properties on the entity type, which is possible in the data files. So we can have properties on the entity type. Those are also like manually added right here, and that can be easily generated. I would hope. Okay, this is a little bit special, but I don't think this is an actual entity type from the game or from the editor, because we have some entity types are on the editor side, and then those are the ones that we actually place out in the scenes. But then we also have like extra entity types that are only in the game code, that things like only get spawned perhaps in the game code and stuff like that. So that's not entirely like easy to do, I guess, in the game code. I mean, technically we could probably, if you have a projectile, you could create an entity type with only the projectile, and then you could perhaps say add a property to the monster that spawns projectiles that says, okay, this is supposed to spawn this projectile or something like that. But yeah, there's a lot of other things like where do we spawn the projectile, offset to where the monster is, and so on, the timing, and what are the properties of the projectile and so on. Yeah, so there's a lot of things that still, is sort of hard-coded, you could say, in the code. And that's fine. This is just, the editor is just to be able to more visually be able to create the scenes and, more easily test the scenes and all that, and visually see what's happening and stuff. So it's, but I don't want to move everything. I don't want to have like everything that is possible to do in the game is going to be possible to do in the editor. It's more like the editor helps out where it can, and then the rest is handled by the game code. So that's how I want it to be. The editor shouldn't be this super complex thing. It should just be a simple editor where you can basically just place things, and then the rest is handled in the game code. That's the philosophy that I have with this setup. But anyway, so let's see. The thing is, these properties. Well, as you can see here, we have. Well, these are not really properties. These are like inherent, I guess, properties that exists on. These are kind of like special entities that comes from the editor. except for this one. Everything that has property on it is an entity type. Anything that has this is just it's like a special kind of entity. And also we have the point. That's right. Oh, the points also we could export or generate into code. So yeah, so maybe it isn't that straightforward as I first was thinking. But we could do something that is kind of parallel to this, because right now these entities are kind of intermixed. I would probably wanna. Yeah, I would probably have something that is separated. So basically, all the editor-based, or all the entity types that are defined in editor could be generated into one place. And then, I mean, I guess we could also generate the. No. I was thinking like the entity entrance and exits and stuff. But these are basically no. These are not like generated. We don't. There's no like data files that describe this entity type, really. So, but anyway, I think we're just. I think I just want to make the generation, and then I might not use it right now, but I'll just make it, and yeah, and then it should be, and then it should work. So what I want to do, first of all, I want to separate this a little bit. I don't want to keep, well, maybe whatever. Let's keep everything in one file here. So we have this animations JSON. We need to find like entity type. All right, so this is the entity type JSON type. So I'll just copy that, paste it in here. Now this is not the entire thing, actually. We also have properties. But entity type JSON. Also this doesn't need to be public. Oops. Okay. Hang on, so this is only for animations. Animations out file. Whoops. Whoops. Come on. Okay, let's also create one for entity types. Okay. Now we need to get the properties in here as well. Now this would be like the original property. Yeah. So we could go to the editor code and we could look for the property stuff. So here's all the properties, different properties, and yeah, I think I need like the, hang on, scene, no, yes, scene versions. This should include the property somewhere. So here is like the JSON, whoops. Okay, these are all the same. So here's the JSON like representation of these properties. So I'll just copy all of that. Put it here. And we need to slightly modify this a little bit. Let's also call this like JSON. Do we really need this tag here? I don't think so. Or we do. Okay. Oh, the asset type. Okay, so we do need this tag here. Hello, Blue. You thought that I wasn't gonna work on the game today? Did I say something else yesterday? I don't remember. I thought I said like I was gonna stream at least. Maybe I said something else. I don't know. I meant to say that I was going to stream at least. Wait. Oh yeah, this is in the other. Here we go. All right, so we need this as well. No. All right, and let's rename it to JSON. All right, so all of these like UUIDs are gonna be just strings. There we go. Yeah, so now we have, oh yeah, we also need the add properties here. So let's see, where is that? Oh yeah, so we have entity type. Wait, no, this is the scene, right? This is the scene, that's right. So I need to go to entity type. Here is the whole entity type. So there's the properties. We also have like an icon, but I don't think we need that. That's only for the editor. And version is the one that's missing. So icon versions with ID, name, hitbox. Yeah, that's. So yeah, so it's just properties. And then property object. JSON. There we go. So now we have everything there. So this property object is basically like a definition of what properties that are on the entity type. And then when you create an entity instance of that entity type, you can populate this property. So this is basically like a template. And then when you have an instance of the entity, you can populate the properties, like, you know, imagine if you have like max health or something like that. So on the entity type, you would just define the max health as some kind of integer or something, and then on the entity instance, you would actually assign a value to that property. Okay, but now we have those. So the idea is that we want to read the properties for the entity. So first of all, we want to read what entity types do we have, what are their names, their IDs and everything, hitbox, and what are their properties. And the properties, what I want to do is I want to parse this property object JSON and create the same kind of struct type that corresponds to the property in question. That's what I want to do. So yeah, so it's gonna be a bit of work here, but I think that's gonna be cool to have. Now let's make an example, I guess. So if we open up the animations, no, generated animations. So I think I want to have like a similar thing here. We have a kind of generic type that we can use to easily create these types. We produce the ID, so we provide like the ID is like, that's like comp time known here. And then E is like just an enum. In this case, E is just an enum of the different animation names that we have. However, this is going to be a bit different with the properties, because I think we need to provide, like, this is basically, what I try to do here is everything that is different for each animation is defined here, and then we use this generic type to actually generate the whole thing. So yeah, so what is different? That is going to be like these things, but those things are data. They don't need to be corresponding to types. That's also like, the thing here is like, yeah, these are types. The thing that's different is the types, not the data. Well, the data is different, but it doesn't need to be shown here. The data is going to be loaded in later, but what's going to be different here is the type. So it's basically going to be just the ID, because that we can hard code in here, and then also the property struct is going to be different. So basically it's going to look the same, except this is going to be like the property struct, and then yeah, I guess that's the only difference actually. So if we start by creating this type here, I'll just copy this actually. And here we have like the entity type. I want to create, okay, I'm just gonna create entity type generic. Well, for one, I want to say, Blue, I really like your design. I would actually try to think about how to implement that monster as well. The monster that I had in mind was more like it's not like standing on all four. It's more like it's up on two legs, but it's like a humanoid, but it's like hunched over, sort of like ape-like, but it's not like, you know, it doesn't move on its knuckles or anything. It's just like, it's a humanoid, but it's a little bit like hunched over. That's what I had in mind. But basically, yeah, and you know, rocky feet. The head is kind of like a lump of, you know, I don't know. It's just with no eyes, no mouth or anything. I was thinking also to have like just like a red glow from the head in the center. Something like that. And then maybe it could grab like sticks from the ground and like fight with those or something like that. Alright, so this is entity type generic. What we receive here are the props. So this would be P for props. And then this is the UID. then let's see. Yeah, so we will return this type, except it's like populated, basically. Well, it's not populated here, I guess. Hitbox origin is a vector, so let's import that. No. And hitbox size. And I guess we would need a resource to load it in as well. We don't need to load in the properties, but we do need to load in the texture ID, these things here. I guess technically we could hard code those as well, actually. So we don't even need to load in the entity type at that point. It could just be baked in here. You're getting better at drawing with thumb. Yeah, I mean, it's amazing. I mean, being able to draw that on the phone or whatever, on the tablet or something, it's amazing. Euro works on 2 legs but stumps with hand. Ah, I see. Well, mine is more like it actually has hands to grab things. It's more like a humanoid and not like an I mean, I guess yours looked like sort of like a moose, but like large like a more larger body, like an elephant moose. If I'm gonna try to describe it. But yeah, as I said, that can definitely be another enemy. No, okay, yeah. So basically, what I mean by hard-coded is not actually hard-coded, but it's, I mean, okay. Hard-coded as in we generate code that has the values in it. But the values are fetched from the JSON files. So I save my project. It has all the JSON files. All the hitboxes are, everything here is, exists in the JSON files as values. So we can just as well just hard code those like in here in the generated type. So basically, this guy could take just this whole struct. What we could do is we could say entity type generic options, and then you would receive like a comp time of that, and this would include like p is a type, or this is like properties. This is a pretty, not usual thing here to have, at least for me. And then we have like texture ID is a UUID. Oh yeah, we also have ID. So this is basically same thing here. We have like hitbox origin. Hitbox size. And we don't need resource, but basically this whole thing will be comp time, and all the values will be known at comp time. So if we receive this, we can simply say now that this is gonna be options.id, options.texture ID, options.hitbox.origin, options hitbox size. Now these are like the default values, so it's gonna be like stored in the type. And then we also have properties, and that's gonna be options.properties, the type. That's the type, but we don't. Oh wait, we have a type. That's right. The type is what we want. This is, yeah, okay. This all loading data from JSON happens during a loading a level? No. It happens when you when I compile. Or like, yeah, a step in the in the build system. So it's all gonna be available when you run the program. So first step, you save your project. You have all the JSON files. Next step, we compile those JSON files into Zig code. Then we take that code and use it in the game code for our benefit. And for example, let's say you have an entity type that defines a property that has like max HP or something. And then in the game code, we would actually get that type. We would actually see, get like auto completion, type safety, everything. Because right now I'm manually defining all the properties. I'm mirroring the properties that I define in the editor. But here I will actually be able to like generate the property types from the editor, from the JSON files. So that's what I'm trying to do. But here I the thing here is like these properties in this stage, like this is an entity type, so it's not an instance of the entity. It's not an actual like entity out in the wild. It's an entity type describing the entity. So these properties are actually not really it's only a type in this sense. So this should really like return like a comp time. I mean, it returns a type. Actually, let's not have this as a field. Let's have this as a function. Also, we should like remove all this. We don't even need to load this as a resource anymore. So this whole load thing is gone. The resource, it makes sense to have a load for animations though, because you might not want to load in all the animations at one time, even though I'm like doing that already, but whatever. Because I don't have that much stuff, so that's fine. But anyway, so here, and then we have a function that's called like properties, which returns a type, and this simply returns options.properties. Yeah, so we got all this hitbox stuff is hard coded. We can even get like get hitbox turns an ABB. Const hitbox origin size Yeah, so now we can get the hitbox like that. Yeah. So it's like hard-coded, except it's like generated from the JSON files. It's yeah. I mean, like when I say hard-coded, I mean like the hitbox origin is read from the JSON file and then put in as code, as like hard-coded in the code. But it's actually, you know, I guess philosophically it's not hard-coded because it's generated from a JSON file, which you can change. It's what you would call it? It's software, but it's even more soft because you can change the code using in the editor. I don't know. I think the Unreal Engine started to use a term called baking a long time ago. And that's maybe this could be part of that. I don't know. I think what they do is like, you know, compile a bunch of shaders and stuff from all the configurations. So basically take like configuration, compile to code, and it's like basically like a one-time thing you have to do when you start the game or something like that. But also it could be like platform agnostic, I guess. I don't know. But then you would have like a compiler with it as well. Anyway, I don't know. Maybe, I don't know what I'm talking about. Maybe that's not how it is. Okay, anyway, so now this should be good. We also have like... So the thing, yeah. Now what we want to do is we make a struct that is a bunch of these that correspond to the actual entity types in the game. And the thing about these functions is that they are static. If I want to fetch the texture ID, I could also do like get texture ID. Actually, I could just return options. We don't even need these fields. I mean, technically, we just need these options, to be honest. But it's nice. It is nice to have these functions and stuff. So we don't need to create this. We can just say options instead. Yeah. Baking lights, yeah. Will there be changes in the game? Maybe. I've been thinking a little bit about that, like adding a little bit of, you know, I don't want to do too much weird stuff, but maybe something with lighting. We'll see, though, because, yeah, I'm not that good at it. Oops. Like, I showed you, I think I showed the Zelda 2 clone that I tried to do in Unreal Engine. And the lighting was, well, for me it was hard to get it, like, right. And also that involved, you know, it had, like, 3D-ness to it, so... It's basically, it was a bunch of 2D planes in a 3D world where they had, like, different... You know, they were moved in the third dimension, like towards the camera or more away from the camera, and then the lighting would reflect that. So if you had the lighting in front of the plates, like more towards the camera, so the light was more towards the camera than the plane was, then you got a lighting effect on that plane. But, I mean, this game, I'm just using Raylib. I'm just using 2D. There's no 3D involved anywhere. There is a way to use shaders, but I would have to really think about how that would work in this game. You made your first color triangle thing a few months ago. Oh, nice. That's like always like the first achievement. But such a cool thing. I mean, to get the computer to actually do, you know, what did you use? Like OpenGL or, let's see. Yeah. Okay. Let's try this. Actually, it's probably easier just to do this. Actually, let's just put this in here. Put everything as comp time. Remove this. We don't need to say options everywhere. Yeah. This could just be. Actually, this could just be properties like this. That is now shadowing, so let's do that. Fine. Okay, so we have the ID. We don't really need the ID, I don't. Well, we need ID to map. I guess, yeah, we need ID to map an entity to an entity type. OpenGL, GLSL. Yeah, sure. Cool. I also made my first thing there in OpenGL. Actually, it wasn't really. I mean, it was more like WebGL, but that is very similar. Okay, so we have our generic type. Now, if we go back here. So what we want to generate is basically the same thing as the animations here. So we want to generate entity types. This is going to be a struct like this. We're going to have the same thing happening here. Here we're going to basically, we don't really need to break here though, I don't think, no. We just create everything. Okay, let me copy this. Entity types. So this would be entity types, and yeah, something like this, you know. But then you are gonna be entity type generic, and then yeah, like this. Import. Alright, so first there's the ID. We also need L. Then properties. So here's the properties. So this is basically going to be a struct. So this is where it's gonna differ also a lot with the types then. So this is gonna be like a struct with all the properties in it, generated from the property template that we have in a JSON file. Alright, and then let's see, texture ID. So this is gonna be another ID, and then hitbox origin, hitbox size. So these are gonna be, you know, vectors. So origin size, something like this. Yeah, and that's it. And I would just repeat that. The hardest part will be the properties to generate that. All right. Let's see. Oh, I thought you were gonna show the code. Cool. It's a Sierpinski triangle. Showing off my maths knowledge. Well, it's not really a Sierpinski triangle, but it's on its way to be there. I mean, yeah, I guess you can't have a Sierpinski triangle, a real one. But yeah, cool. A fractal pattern. It's like, it's also, you know, the Triforce. How many Triforces are in there? Okay, let me show. Maybe can open this. There we go. 1, 2, 3, 3, 9, 27. 1, 2, 3, 4, 6, 9. Yeah. All right. Awesome. Yeah, that's the first step. Then you're like, well, how do I make the next thought that I had was like, after I made a triangle, okay, but how do I actually make like different things now? How do I have like several things at the same time? You know, all kinds of questions. With no answers at that time. And it all seemed so complicated, like the OpenGL like API and everything. It just seemed so like complicated, and yeah, I don't know. It was hard to think about. Okay, but how do I do this? How do I do anything? Okay. So let's see. So this is the animation. Let's actually break this out in its own function. Yeah, this is like generate animations. And I don't think we even need anything. Oh, we need the animations. We need asset index. Yeah, that's an asset index. And we need an allocator. And we need a directory. Okay. Try generate animations, allocator, dir, asset index. Right. So now we're back to that. Now we want to do the same for entity types. So I'm gonna do that. Oh shit, sorry. There we go. Thank you. It was definitely different what I expected from normal programming. So why is it like that? Yeah. But then when you get it, it's like, yeah, you. I mean, it makes sense in a way. And I guess also why it's so performant is why it's like you have to define these arrays of points and everything. But some of them are kind of weird, like I don't know, it feels like the primitives, you have to sort of read about them to understand how you would use them in a good way. Like what's it called, like strip line, or no, what's it called? Yeah, all those different like ways of doing things. Yeah, so this is generate entity types. All right, entity types. Now these are entity type JSON. So this would let me double check what this is called. Entity type JSON. Yes. I'll just do this for future easiness here. So we can just change this, don't have to change much else. This is gonna be like the source. I like to use like generic names because it's, you know, it's more easily changed. So extension. Okay. Now if it's 0, we don't really need to exit. We just, I guess we just return. We could also like truncate the file or produce a file with no, I guess we don't, this doesn't really make sense anymore. Let's just remove this. The out file, right. No, this is entity type. Could not open. Yeah, sure, let's just crash, whatever. We got our generator up. Alright, so here's where we do this stuff. So we need L, yes. We need entity type generic from entity type generic. Alright. Now this one will skip. But I do want to keep the iterator. This is entity types. Yeah, I think maybe we'll do it like this. This whole thing here, after generator, I think all of this I want to put in a separate function, which is going to be like write animations. And the only thing we really need here is the generator. And then instead of doing this, we are going to do generator.writer, because that's the same thing. Okay. And then here we will just do try write animations generator. There we go. So now basically this, the idea is that this function could be now like very generic. I'll just remove this here for now, and so we can more easily see what's happening here. So let's rename this to like generate, yeah, just generate. And we have a bunch of options. So these things we can move in here. We can have a comp time JSON is a type. We have extension. We have out file. Is a string. Yeah. Here we go. And then all this we will put in write entity types. And now here we will call generate function or write function with the generator, and we can pass in the write function here. So this would be the write function. This is a constant pointer to a function that takes a generator and produces some kind of error. And of course we have to do that. All right, now we can remove this one. So now we only need this one thing there. So now we can say generate animations JSON allocator animations out file extension is animations.json third asset index and then write animations, and then we do the same for this guy. Entity type JSON allocator types out file entity type as the index and then run entity types. There we go. Cut off a little bit work there. So now we can focus on only the generating the things here. Okay, so we have this, we have that, a struct. Yes, we go through all of the things. Oh yeah, source. We need source as well. That is true. That is true. So we need source. Now that is gonna be. Let's see. What is this? It's this. Yeah. There we go. Let's just make a more convenient function for that. Let's make like JSON array function. That is a type. Man, I wish it had like shorthand function. Alright, so this is JSON array animations JSON. This is JSON array JSON. All right. Now, okay, so now we can open this up again. So here's the entity types and abstract, yes. And here's a list of things. The name we will have to also get. That is the name. And so that should be the same, but this is not the same. This is gonna be like entity type generic. Right, but this is not a block. I gotta ask you, what features of the language you use a lot and what you don't? Good question. The features of a language. I mean, I try to find a place for all the features, but yeah, I don't know. I always try to find new, like exploring new patterns and find like where everything fits, and then trying out new things all the time to like expand, you know what, and then recognize, okay, well here this pattern would work really well, and here this pattern would work, and here you can do like this or this or this or this. So I really try to, like, you know, keep it open. But I would say, like in Zig, one thing that I really like is making an enum or union enum, and then have it, and then the switches on it, because it has exhaustive matching on the switch, so you have to implement all the cases. That is like a really nice feature, I would say, in Zig. and incidentally, that's also the case in Haskell. But man, other like okay, I don't like inheritance. I would say inheritance is just like it feels like sometimes it could work like in very like contrived examples, but I usually also like classes in general. I try to stay away from actually, because I don't know. It just feels like you're forced into some weird world. I don't know. It's hard to describe. It's like classes is probably my least favorite thing in programming. But it does have a place. It's like, yeah, if you need something that needs to have a constructor, you know, something that happens when it constructs, something that happens when it is destroyed. Yeah, then it's a good thing to have. But I mean, yeah. I don't know. It's just there's no like I don't back up this with any data or anything. It's just my personal feeling towards the thing. If I have like I don't mind classes if it's like you have to use classes to program in something. That is okay, fine. I guess I have to. I don't know. I don't like it when there's like a whole bunch of magic things happening either that you don't have control over or that you don't really see or understand. Of course, that I think many people would agree with that. But what else? Like operator overload. I'm kind of I don't know. I feel like overload. Like okay, I like it how Haskell does it, except you get all like because in Haskell you can define any operator you want, and it can look in any way you want basically. So you can have an operator that looks like this, and you can define whatever it's gonna do. Haskell stream. Man, I don't know if I dare to do that. It's been a while since I've done some Haskell, and I'm gonna be honest. I'm not really that good at it, but I just like the problem with Haskell is basically it feels good for a while, and then you run into some issue that you find is like almost like it feels like it's impossible to solve because you just don't understand what's happening, and that could be all from forcing expressions to not be lazy, which can be a problem if you want to have operations depend on each other that needs to happen in a certain order. Because everything is by default in Haskell is lazy, and then also when you use like a library that uses some super complex, at least to me, like type system that you just don't understand. And you're trying to use it and you get this weird like 100 lines of code error or 100 line error that you cannot read. And so yeah, that's the problem I have with Haskell at the moment. But yeah, I can definitely do like a little project in Haskell. That would be kind of cool. OCaml is easier than Haskell. I don't know. I've never used OCaml. I've barely seen OCaml. I've just heard about it a little bit. And then there's like even crazier languages than Haskell that has like the proof, like the mathematical proof languages, those kind of languages, or even crazier. With the type system. All right. But yeah, I could definitely one stream we could do some Haskell. I just have to have the setup and stuff. Maybe that's part of the stream to see how you set up the thing. I don't even know if I have Haskell on this. I don't remember. Anyway, and they also like change the tooling all the time. It feels like, I don't know if you should use Cabal now or Stack or something else. We'll see. Okay, this is like a function call. Let me just make this here. Actually, let's just do like, so we have this block and stuff field. Yeah, let's do like, so I want to have these things, and instead of enum, it's gonna be call. Okay, now we have like fun for function. So fun, and there we go. So that's the function call. Then we have a call argument. Org indent, new line, yes. Then we have end call. There we go. Now we can use this instead, a little bit easier here. So let's do begin call, and we don't need to indent. And here, and then we do like, let's just get rid of all this crap here. Okay. Call argument. Now the first one is gonna be the UUID. So actually we need to do that. So this is gonna be this part. Except I'm gonna make a print version of this. So compile format, and then args, and then this will be args and format plus new line. Actually, there we go. Oh, that was weird. I don't know what the selling point of Haskell is. Why do many people learn it? Well, for me, I can't talk for everyone, but for me it was I just saw some Haskell, and I was instantly curious about it, because I'm very curious and interested about different like programming languages, and I saw Haskell and it just looked so different and so like, you know, stripped down and elegant that I just had to understand it. Yeah, It was just crazy to me. And I mean, it just looked so elegant to me. I don't know. It's just how the code looked, like the aesthetics of the code. All right, now this is gonna be the ID. Yes. There we go. You've never seen a product? Well, I actually saw, someone made like a Quake 3 Arena clone with it. Like an FPS shooter. Maybe not a full clone, but it was like, it was, running around in a 3D world and shooting and stuff. I think Facebook actually used Haskell as a... I don't know if they do it anymore, but they did say that they used Haskell as some kind of... I don't know what it was, like a load balancer or something like that. Oh, excuse me. Oh, man. But I don't know. I haven't. Oh, shit. I haven't really looked for that. I mean, I know it's possible. It's just there's a problem. Oh, my God. I'm dying. No, I think the problem is basically there's so few people that know Haskell, and that's not a good business decision to start a project in Haskell when you have barely people know it. And that's just the way it is. It's like most people are familiar with imperative programming. It's shifting a little bit, it's shifting because of major program language like C#, C++ has introduced concepts that come from the functional world. Such as in C# you have like select many. Those are actually like functional programming concepts that are equivalent to map and bind, and also you have like filtering, things like that. So it's a lot of the concepts actually have now merged, you could say, into the imperative world. I guess except for C. No, but yeah. So there's much more overlap. So now I think it's easier now to get into functional programming, or maybe even start something that uses functional programming. But it's also it's always like a risk, as a business risk, because of it's hard to get, I guess, the competence to actually build something in that and keep it maintenance and everything, and have it like actually work. So I think that's one of the reasons why it's not really popular in like the business world. But it's really, I think Haskell is it's really popular in like the research world. Or like I've seen it like in the schools and stuff. It's, I don't know, just learning about programming, I guess. It's like, yeah, it has a lot of reasons for that. All right, so we got the ID. So now we should. So next up is actually the property. So I think I wanna have a generator for that. So I'm just gonna say write properties, and I'll pass in the generator, and then the entry value pointer dot value dot. Actually, we don't need to dereference. Actually, yeah, we don't need to dereference here. It's automatic. And then properties. Yes. So we want to write the properties. All right. Then then when we've done, so we just imagine we have that, then we're done with writing the texture ID. No, not texture ID. What? Wait. What do you want? Texture ID? No, we don't need texture ID. There's no... Yeah, we don't need the texture ID. Fuck that. There we go. Oops. Alright. Okay. So now no, this is gonna be like end call. Okay, so the properties, and then we need these two vectors here. Generator call argument print, yeah. Thank you. So this would be like that. Actually, if it's a vector, no, whatever, let's use this. Entry value, pointer value, hitbox origin, 0. And then the size. Yeah, basically like a fancy mapper. This is just a fancy mapper we're building here. Okay. Write properties. Right. Now we need this magic function here. Write properties. Okay, I think we can get rid of this now. Source is gonna be whatever this was here. Oops. Object JSON. All right. So first we begin with a struct. Because it's an object. So actually, yeah. So I think we want to have functions, since this is going to be like a recursive. So basically, we want a function called write property, and that's a property JSON. Yes. Now each one has an ID, but we don't care about that really. And then this one would basically switch on this one, because this is a union, tag union. So we'll switch on that, and we get all these different things. Object we already have. I'm gonna yeah, just try write properties, and here we get the object. I'm just gonna call this P for property, and that's the actual thing we want to do. And then we just need to implement everything here. But basically, an object would just be so we have the source, we have the map, we can make an iterator. we can loop through it. We can look at the name and the, so this is just gonna be generator, struct field, identifier is the key pointer, the type. Oh, yeah, so this, oh wait, we have, I think we have like begin struct field. Yeah, begin struct field, there we go. So that is, this is for like a shorthand, but here we have like, we begin struct field, end struct field. Okay, so now in here, I mean, yeah, we just do write property. And this is going to be the value. And that's it. Now we're done with the object. So it's pretty simple, but there's just so many of these. Let's do write array. So now the array is actually going to be actually this is a bit different. Hang on, I'm gonna check something here. No, actually, you know what? I'll just generate you know, native sig types for now. We'll figure it out from there. Because I had like I had a whole system for defining the properties easily, but I was thinking like, should I reuse that? But I actually don't think so. Maybe we'll see. Okay, so the array will be I mean, it's just gonna be like writer. It's just gonna be this, so a slice, and it's always constant, really. So we're not changing these properties. So I'm gonna say const, right? And then we need to put in the type that is the child of this property. So I'm just gonna say no wait, write property, and we have the source, actually generator source, and the subtype is just a tag. It's not really this, because the subtype, oh yeah, this is not populated at this point. Yeah, we don't really have items actually, so we should actually just remove that, I think. Yeah, we don't actually have the values. This is for the scenes. I guess that we can keep it. Yeah, items is not populated. However, subtype is. And the subtype can be anything here. But that's what's confusing me right now. I'm pretty sure I can have like arrays of arrays? Question mark? Yes, I can. But how is that? We don't know anything about this type though. Okay, so I guess we don't have arrays of arrays. But that doesn't matter because I'm probably never gonna have arrays of arrays anyway. So I'm just gonna ban that. I'm just gonna look at the subtype, and it basically cannot have. This is just an, yeah, it's just tag. It's just an enum, so it doesn't have any more information. So basically, what this is gonna be is it's basically just gonna be. It cannot have like further properties. It has to be a primitive basically. So right property, I guess we'll make one that's called like from tag. Actually, you know what? No, I guess that's fine. This, but let's rename this like primitive. And then instead of taking property JSON, it's gonna be like tag type or whatever it was, tag. And then it can't be object. Alright. And then this is like object or array. But if it's something else, we're gonna use primitive. Oops. I think this can be coerced, so let's keep it like that. This is not used, but it will be. Okay. Yeah, this is all we should be doing, and then no, that's it. Okay, that's array. Now we have all the other stuff. We have asset reference, all this. Let's start with the easy ones. I'm just gonna put them all here. So we can alright. Boolean. We could just put this right straight in here actually. Is it bool or boolean? I think it's bool. Float is gonna be a F32 integer. I don't know, I32 string is a string. Why is the colors messed up here? Oh yeah, because I used the wrong. There we go. Asset reference. Now these are interesting. It's we should have something here. It's a tag. No, it's not. It's this asset ID type. Oh yeah, because this is okay. We're in the tag mode. But yeah, okay, basically we can do let's just do like write asset reference, write entity reference, so this would be a struct. No. Instruct. And struct. And then we have struct field, which is asset ID. That is a UUID, so this will be UUID. And then actually it's also not optional apparently. And then as a type is a document tag JSON, okay. What the hell? Oh, I see. This is the type. Okay, so this is format, and then args. There we go. So let's do like print here, print. And this one is dot s. No wait, this is the type. Man, I'm confusing the two concepts here. The type. That's like a document tag. Document tag. Which we don't really have in the game code actually. But I don't think we actually use this asset reference right now. Right, entity reference. Right, so this one has scene ID and entity ID. Which both are UUIDs. And I guess they both are optional. Okay. So actually I could probably I was thinking like making a struct and then actually supplying a struct or supplying a list of arguments now. Whatever. Okay. Anyway, so now we have a whole bunch of things in here. So let's see if this works. Is that it, actually? I mean, I guess so. Let's try and run it. Wait. No, this is... 359. Unable to resolve inferred error set. Right, because it's like recursive. I guess it's whatever error that this has, which is whatever error this has, which is this error. So it's like standard IO writer error. What? Oh, why did I do that? Write function. Oh yeah, you need source as well. There we go. 380. Oh, hang on, I'm just gonna check this. I don't know what's happening. Cat's going crazy for no reason. Alright. Okay, where are we? 380. Expected 3 arguments. Oh yeah. There we go. And there we go. Now we should have our types here. Looks a bit not great. Let's see what's going on. This struct is not indented. begin struct field. Yeah, that works. And then we do a call. Call argument. Then we do write properties. Oh yeah, because okay, so we basically we need to do an indent manual here, I guess. Okay, so that's that. And then what's going on over here? Right, so at the end of properties, we also need to end this argument, which means we do like writer, write all. There we go. All right. Now let's see. Man, why do I always do this now? This is crazy. I think I lean towards putting single quotes because I often programming, you know, TypeScript, which you can use either. But I usually use the single quotes because they are easier for me to reach on my keyboard or in my like keyboard like layout setup. Okay, now we're missing a comma here. That is end of the call. This should also be end of the struct field. Yes. There we go. There we go. Now I think, yeah. Awesome. So now we have generated all of our entity types as well. And we have our, you know, property structs here also generated, which is great. And we got our hitbox here, and this one doesn't have anything in properties. Most of them doesn't. It's only the devices basically that have properties. Here's a button, it has like activates, and then there's a reference to some entity in that scene. So yeah, cool. Chest with the loot type, so we can see all of, so basically, yeah, generating all of the different entity types now. Now the only thing left is to, like only thing, but basically figure out how to use this in the game now. But I just wanted to do this to like, because it felt like such a nice you know, upgrade here to do this. The thing is though, okay, there's one mapping left, and that is when you read in a scene, you do get this structure, except it's like the property structure. So basically how we're doing it right now, let's see, scene. Yeah, so we'll take, for example, the door. Very simple thing. It just has one initial state, property, and we define it like this, property and then boolean. So if I can get a version of the properties type described like this, I can also make, because this type is now readable in the JSON format. So yeah, so when we read in the scene, we have this entity which has an entity type The type is a union enum, so it's any one of these things. And then each one of them has these properties that is defined like this. But this property is not just like, it includes the type in the actual JSON data. So we have to sort of look at, wait. Yeah, we have a property boolean. So each property has an ID and then the underlying like property thing, which is a type. So this one has like a boolean. This is like an enum, like a union enum. So it has like the name of the tag, and then it has like, you know, the underlying like the value here. So this is how the JSON is structured for a boolean, and we need to basically convert the JSON into this format as well, because if we have this format, then we can actually load the JSON with this type. It corresponds to the actual JSON structure, so we can load it in like with that type. So so let's actually try and do that. So basically we have this entity type generic. I mean, okay, we could introspect on this type to actually produce a type. That is possible. We could also just generate this as well. I mean, I think probably generating is the easiest. So it would be like, this would be the property, like kind of like, you know, a Zig version of the properties. And then you would have the JSON corresponding JSON here, which would be like activates is a property array. No, wait. Yes, activate and then asset reference. And then this one would be like time is a property float. So I want to generate these things. Let's keep, actually we'll keep it that for reference. No, here. So where are we? This is the properties. So after the properties, we want to write also properties JSON, I guess. And then I want to make a map. So when we've read in this, we can actually, we map it to this, because then it's way easier to actually, you know, use it in Zig. So we read it in like this for JSON, and then we make some sort of mapper to map it into this. Maybe we can even generate the mapper, actually. I don't know, we'll see. Okay, so now we just need to generate the other one. So we basically need to we need to make like a mirror version that is the JSON. So let's just copy everything. Of that. And put it there. So now we'll put take everything here. We'll do like function Why am I not seeing anything? Ah, S. There we go. Alright, there we go. Now we just need to populate them. So object is still gonna be the same. I think so. I don't think anyone actually has like an object in that sense. This is gonna be like JSON. Yeah. So array JSON will be dot array and then also actually these will be key pointer, and then we also have writer, write all property. And after that we need that. Oh, am I doing it again? Yeah. Yeah, array. And then the primitive is, that's fine. Property JSON. Yes, that's fine, except all of these need to be JSON. You also JSON. Probably the most common. Oops. Common name in programming right now. All right, so here we go. So bool is just now we need, it's just dot boolean. This is dot float, dot integer. I don't think we even use that. No, we don't even have dot integer. Okay, whatever. String is a dot string. Then we have asset reference. We don't even have a thing for that, but I will just say the same thing here. Asset reference. And the entity reference is the same thing, except it's entity reference instead. There we go. And then the asset reference, these we don't need. There we go. Okay, so let's see what says here property array. Yeah, cool. Now we only need to like import property so we can. So do we have it like here? Yeah, this is the one. So we basically just wanna say this. So we want not an import. We're gonna do like a const, begin const, property, and we're just gonna write scene property and const. There we go. There we go. Okay, so no errors in the file. So now we have all of the entity types. We have their Zig friendly properties struct, and we have the JSON equivalent. So potentially now we could just use this type to actually load in the JSON for those entities and then map them here. So let's see. I'm just trying to figure out how to do that though. I mean, we could do because yeah, the way we're doing it right now is basically if you have, let's say you have an entity reference, then you have this entity reference and you can just call like get entity ID, so you get the ID out like that. But instead of doing that, if we can map it to the Zig friendly version, we can just say entrance.entityID instead of doing that. So that's way more friendly. But the problem is now we need to map this to this. Is the issue. We don't even have this type, but this would be this type. And then wait. Yeah, this is the return type here. This is the body. Why am I getting... Okay. And it's like... and this is also one of the problems you can see right here. If you have a property and you try to like get something from it, there it's like you get all the types because it doesn't, the LSP doesn't know which one it is. So even though it is an entity reference, but it can't like figure out which type it is. So it would also be a nice thing to... No, this is scene ID. I think we just need to do like manual mappers. I guess it is possible, I guess. to do something like this. I mean, we just need to, we create this function, that should be easy. The type is the same. Then we just have a body with return, and then the return is just gonna be this expression here, and this could be like recursively generated as well. If we have an object, we do this. Then we all go through all the fields, we do this. Each field, so this, and then this is the value, and then self is gonna be the source. But we might need to keep track of where we are. Yeah, because we need to know that self. Or we could have functions that do it for us. We could have like map entity reference, because we know it's an entity reference. So we could just have map entity reference and then this. Yeah. Okay, so it's definitely possible. Yeah. But it also, we could also like retrospect on, or introspect, but then we wouldn't get. Okay, well. And it's only gonna work for shallow objects because, yeah, we don't have support for non-shallow objects right now. I think I'll leave it there now, though. We have but we could progress there if we want. But I think I'll leave it like this for now because I just feel like it's gonna require so much to tie the knot here. I mean, I guess it's better to do it now than to do it later, I guess, if we want to migrate to this sort of thing. I just wanted to see how easy it was to just generate these types here. But yeah, cool. And we even get this type, which is what's very important. Now the only thing is like mapping here. But even if we just have this type, we can still use it, actually. Yeah. The problem is this, though. I don't think we're gonna use... Yeah, this should correspond to the name of the entity type and not the file name. So, actually... Yeah, I want to change that, actually. Because we do have the name... So we don't, yeah, this is not the name actually. What we have is we have entry, value, name. That's the name. So the name is this. There we go. There we go. Now we have the actual name here. Cool. All right. Cool. Actually, you know what? Let's take a break from this. Maybe we should do some Haskell now. I don't know. I maybe need some ideas, some idea to what to make. I just start creating something. I don't know. Okay, so I have to do some research here because it was a long time ago since I did anything with this. So let's go like Haskell. Here's the official site. Look at this. Okay. Yeah, I don't need. I just want to know about the tooling. Excellent tooling. Okay, tell me more about the tooling, please. Downloads. Yeah, so you can download. Okay, so here they say GHC up. Install GHC, Cabal install, Stack, and Haskell language server. Okay, cool. So that seems like a good thing. Installation. Now, okay, I'll install it on Linux. Sure. I'll just paste some random stuff in here. Sure. System requirements. Provides different binary distribution channels. These are collection of tools that made different purposes and philosophy. Whoa. First, we select the base channel. Skip. So you can just skip it. Default. Or vanilla. It's weird that it says like this is the default, and then it's like default is skip. Okay, what? Okay, so is skip and default the same thing? Or if I skip, will it select this? Sure, let's go default. Detected bash. Good. Do you want? Yes. Prepend, append. Append, please. Do you want to install? Yes. Do you want to enable better integration of Stack with GHC up? This means that Stack won't install its own GHC versions but uses. Yes, please. I don't want to have a bunch of double stuff. So Blue, are you still here? You have to give me an idea of what to do. Like a small project. I'm gonna grab something in the meantime here. Okay, let's think of something. Okay, it would be cool to make like a a roguelike. No, I mean that sounds daunting, but it's basically just you know, the old school roguelikes. So what I want to have is basically just a you know, little at symbol or something that goes, that like can just go around on in the terminal, basically. So we'll start there. Man, it needs to download a whole bunch of stuff. Alright, so downloading Haskell language server. Alright, I guess I can do something else here in the meantime. Maybe over here. Yeah, this place has like a bunch of mushrooms, so we can add some mushrooms here. Maybe the hit particles animation we could change to remove like the last frame. Maybe? I don't know. Well. Alright, is it done? Okay. Alright, initialize new Haskell project in the current directory, run Cabal in it. I thought you would use like stack, but maybe that's like not how you do it anymore. I don't know. Sure, let's just follow. Because like Cabal was like the old original like package management system, but then there was like issues with versioning, getting the correct versions of stuff or something like that. And then Stack was like a solution to that somehow. But now it seems like it's GHC app you want to use. So it's like the tooling is, I mean, it's probably good, but it's just a bit confusing sometimes. Parsing cache failed. Trying to generate cache. Yes. Okay. Yeah, because then you would use like stack to easily install packages. So I think to install, previously you had to like edit a file to add dependencies in the file and then run like install command. You should edit couple file. You may want to edit and add a description field. Okay, well, I don't care about that. Let's just see if the Haskell server actually works. I need to set up my stuff for that though. So here's the main function. It's kind of similar to how the sig. What the hell? Sig generation, like new works. You have like one main file and then a lib module as well. So let's try like how do you run this again? System requirements, next steps. Man, it's just so confusing. Yeah, there's two, like, personally I thought that stack was like easier to use. Two like package management libraries or systems. GHC@vim. Okay, I'll wait with this. Like, because what I want to see is like, okay, there's some cabal. Okay, let's see if we can figure this out. Let's see. So there's like, you can use stack to execute thing. So stack exec, I think. I don't know, man. Build. Okay, it's building something. Okay, there we go. Now we have some kind of thing there. Cabal command. So what are the commands? Run. There we go. Okay. Okay. Up to date. Is that part of? That's just Haskell telling you that it's up to date, I think. This new style. What? This is so confusing. Let's there we go. So we don't get all that crap. Then okay. So I want to make a old school roguelike. And okay, so I'm just to not be confused here, I'm gonna say features move at around the terminal, right? That should be the first thing. Okay. Now, what do we need? I'm thinking like, let's add, I want a way to like clear the screen. So okay, I'm not sure how much of this I'm gonna explain, but oh man. Do we get any? Do we have the Haskell line server here? No. Okay, I'll live without it a little bit. So how do we do this? I think what we just I don't know if there is there a command for this? So, as I understand, if you wanna like move the cursor around on the terminal, there are like escape codes, ANSI escape codes. So you basically just put a sequence of bytes in a specific way, and that will correspond to some kind of command. I don't want to know about the history. No. Okay, this might work, I think. Okay, so CSI is gonna be so here's the code. So basically you have a cursor up, forward, back, next line, blah blah blah. Erase in display, clears parts of the screen. If n is 0, clear from cursor to end. Clear erase inline, part of the line. Wait, so if you if you place this on the top left, will it clear everything? Clear from cursor to beginning of screen. If n is to clear entire screen. Oh, there we go. So you just do this, CSI to J, and you clear the screen. So we need to know what CSI is. Criminal investigation. 1B. What is this? 033? Follow my end now, include parameter device in the range. Okay. So let's start here. I guess this is like a 1B hex, and then you have this character there. So CSI is gonna be that. I'm not sure if this is possible. But I mean, I guess we'll try it. So let's do that. And then actually, we could just do this. Yeah, so we're prepending, I guess you could say, this into this list here. So clear would be like put string CSI plus, and then 2. I mean, is 2, is that in bytes or like the ASCII 2? Okay, let's just try it. 2J Okay, so this should clear, and then put this, and then this. Oh. Right. How do you make it into a char then? I thought it was... No, that won't work. No, I think it's not. No. Man, I don't remember. I have to look at this. I have to look this up. Haskell char byte or whatever. Char 8. Oh yeah, now we're getting into the, okay. Now we're getting into oh man. The different types of strings and things. Oh yeah, so what you can do, actually, there's a thing called Hoogle. And you can search for, let's say you want to turn an integer into a char, then you get all these results. So this is a really cool tool that you can search up functions. So here's the one, here's like just CHR, which is in Protolude. Okay, there's a thing called that, like the prelude, which is the thing you like always get, which has like all these standard functions in it. So there's a difference from SIG as well. So let's just use CHR. Oh, oops. I forgot this is Haskell. So CHR on that. It's not in scope. Okay, so where do I find it? .char, okay. I think I have to install a package now. No, it's in base though. Okay, there we go. And as you can see, there was something happening. Did we actually clear the screen? And it moved it to the bottom. Hey, it works. All right. Okay. So now we have that. Let's have like set cursor position, and we will take. I want to make. Do I want to make like a vector type, or this should just be like int, and then just IO. So X and Y, and this would be like put string CSI, and now I need to figure out what to put here. Whoops. So we have up, down, forward, back, next line, previous line. Okay, so that puts it in the beginning as well. Horizontal absolute, move the cursor to column N. So that is good. That is like the X version. Can we also have like horizontal versus vertical position? Same as C up, but does count as format effector. So there's only like setting to column M. I guess for line is kind of difficult, maybe. I don't know. And this one reports the cursor position by transmitting this. Okay. Select graphic rendition parameters. And select graphic sets display attributes. Okay, so this is like, okay, so we got like different, you can set like colors and stuff. Cool. I wish I could just set the line immediately. Scroll whole page up by N. I guess in like if you want to have like an actual game, you would probably like move to the top and then render the whole thing, and then move to the top again, render the whole thing. Each time you want to update the screen, basically. Maybe, but it makes it possible to just update one part of the screen. But how do you put it? Cup. Cursor position. Oh, how did I miss this? Move the cursor to row N, column N. The values are 1 based. What? Default to 1. Oh, okay. Default to 1, top left corner. Okay. So it doesn't start at 0. A sequence such as a synonym for 1, 5, as well as 17, same as 17 and 1. Okay. So this we want to do. So H. CSI H. We want to have actually char x. Okay, so basically we have this string. I'm not sure if this is the best way to do it, probably not. But we have this string here. This is append, so we're appending, and this is a string. So append only works for strings with strings. So this is a string, and because first we have this one element, and then we prepend it into an empty array. I'm not sure if you can just put it in the array like this. I don't remember if that was possible. Could it match expected type with actual type in function to one argument? Second argument. Oh. Okay. Okay, so it did work to do that. So okay, so let's do put string at. I think there's like put char as well. Maybe. Yes. We don't call you. Okay, now we get a little at symbol. Cool. Let's try and set cursor position to, I don't know, 5, 5, 5. Oh, wait. Maybe it doesn't work. Oh, I have the semicolon. CSI and semicolon MH. Maybe it doesn't work with this. I don't know. Oh, I see. This is like this actual start. This is a CSI thing. I see. Okay, what happens if we only do this? Right, it just clears the screen like that. I mean, okay, maybe it doesn't work in this environment here. No, it's still at the top left. Let's do this. Let's do like map. Actually, I want to try and print this out so we can see what's happening. So let's do this. And I want a map. Let's turn this into, I guess, an int onto that. And then I wanna put string length, and I wanna read this. So this will basically convert this to bytes, and then back to a string with read, and then I'll print it out, and then we'll forget about these things. Oh, int doesn't. What about following the conventions here? No. Okay. Whoops, you didn't see that. Okay, whatever. I need to find a function that does the other thing. So char to int, digit to int. Well, it's not a digit. No, it is a digit, sorry. Except it's not a digit. I just want the int representation. Okay, so it's the same. Okay. What? No, it's ord. That's right. Ord. Alright, you expected a string found map. Oh no, it's not read, sorry. Read is the other way around. Show, it turns a thing to a string. Couldn't match this with char. Oh yeah, you need to be, there we go. And actually, I think you can just do this. Question mark? No? First, this is gonna get called with X. No. I'll just do this. Okay. 27, 16, 11. Yeah, that's correct. that is like 1B. Okay, I found another function we could use. Show int at base 16. Doesn't exist. Numeric. Wait, what? How are you supposed to use this? Oh, that's the... Wait, what? Oh, okay. So which one is the base and which one is... So we put ord as a function that maps ints to chars, and then a is the integral. No, ints to chars. Okay, so we need this. There we go. No, is this for show string to string? String to string. Wait, how to print integer is a Haskell show hex. Okay, I guess you just put an empty string at the end. What the hell? Okay, so there's a show hex. Let's do show hex. Why does it need a string at the end? Okay, there we go. Okay. Yeah, so we have like 1b, 5b, which is okay, that's the like the square brackets. 2, 3b, which is this one, 1, and then 48, which is this one. So it looks correct, I think. What if we have written something and then run it? Oh wait, did you needed a space somewhere? You needed a space here. Okay. I think. No, now it just doesn't work. But it says here, there's like a space, or is that just part of this? Just to show it better, okay, I guess. Man. Yep. Yeah, that doesn't work. I wonder if it's something to do with like the Vim stuff, but no, it just sets it to the top left all the time. Like clear works, so that was what I was thinking. Like then it should work. Hang on, this is wrong, right? This is wrong. This should be show. Oh. Yes. There we go. Okay. And at the end we just clear, so now we don't see anything. Cool. Yeah. Okay. Cool. Actually. There we go. Cool. All right. Okay, so now we have a way to sort of set this, like draw this anywhere. Now we just need to have like a loop where you would, you know, be able to move this character around the terminal. Let's see if I remember here. So, of course, there are no while loops here. So what you do is you have like a recursive function and I'm just gonna call this loop, and we probably want to have like some sort of state. Now I could introduce state monads here. Hello Blue, finally. Now we're into Haskell land. But let's do this. Let's have we'll have the data. Actually, you know what? I'm gonna move this part into the library. And we'll expose clear set cursor position. Yeah. Okay, well, if you want to... Okay, I can walk you through what we've done so far. So basically, yeah, I installed GHCUP, which is like the tool to install Haskell and all tools, and the language server as well. And then I created this project here, so very like bare bones. So the idea is that I want to create up this here. So it's like a terminal, you know, based game where you move around. So this is the only thing that I have in mind right now, like moving around this in the terminal. So basically, I looked up how to clear the terminal and how to set the cursor position. And if we look at this library here, this is how you kind of do it. So it's basically pretty simple. You just define a string that has certain bytes in it. So this is like a magic byte here, and then this is the next one, and then you add a little. So this is like the prefix of the command, and then you just write that to the standard out to tell the terminal that, hey, I want to do something special here. And you can clear the screen by appending using the prefix and then appending this 2j. So that's clearing the screen. And then here you can set the cursor position, take it to integers, and then we produce a string that is like the prefix, and then we turn this integer into a string using its, I mean, yeah, a 1 we turn into the ASCII representation of 1, for example. And then a semicolon, and then Y, and then H. So that becomes like the command for actually setting the cursor position. So this is CSI commands. So I had to look that up. And here's the main file. So we can import these from here. I don't need some func. Let's actually remove that. This is like the generated standard code there. But let's do like clear and set cursor position. Okay. So now the idea here, so this is what we got so far. So we're basically, so if I show you here, I can clear the screen. I don't want to show this actually. I clear the screen, I set the cursor position to 5, 5, and then I print this here. And if we run this, it fails because I haven't there we go. Set cursor position. Wait. Huh? Program mylib. Oh, I see. I have to. So qualified is okay. There we go. So so now I can put this there. So that's the first step. It's kind of cool. We can use ANSI colors to make a game. Yes. We can make it. So let's try. So should we color this? I was thinking like making the loop. Let's just make the loop first. So basically in Haskell, to loop, you have to like recursively call the function. So here's the loop. However, we should also have some sort of state. But I would just do this first. So this is the main loop. And we set the cursor position to 5, 5 for sure. Let's also... Let's just clear every time, I guess. Oh yeah. And then... And this is like the exit. Alright, so we'll do the loop. And then loop will call itself loop. There we go. So now we have the loop. Let's see if it works. Well, yes, it works. So maybe we shouldn't actually do that. Maybe we should wait until we get like a character input. So I will remove that. And now we're back to normal. Okay. But you drew something. Okay, yeah, I'll check it out soon. Ooh, it looks really cool. Have you played Zelda 2? I'm sorry if I'm always like make reference to other games that Monster reminded me of, but yeah, Laser Scorpio. Awesome. All right, so I'll check it out more later. Let's see. So we have the loop. Now we want to take an input. We want to take like we want to be able to read from, I guess, the keyboard, like standard in. So let's check that out. I guess we'll keep this here. So so IO jar maybe. I mean, this should definitely be like read. Oops. Read line. String, maybe string. There's so many versions like that. That's also the thing. Like, you get like so many different versions of the same thing. Okay, so this is like a read line, but I want more like read character. So like read byte or. How fast is Haskell? Depends on your code. No, but it is. I mean, okay, it's at least as fast as C, because if I'm not mistaken, I believe. Okay, I just need to look this up. Does Haskell compile to C? Yeah. It compiles to C, but is that how it compiles? Okay, it does compile to native code. Okay, so never mind. But it is very close to C. You can actually define, you can actually import C stuff in Haskell and other languages as well with foreign function interface. So you can create like bindings to, there's bindings to SDL, for example, as I've seen, like SDL2. That's just from what I remember now. Okay, get char. Okay. Get char. So at the end, we will get, so let's make a draw function, which is gonna be this part. And then we'll make an input. Get char. So first we do draw and then input. So we get this. All right, now, I mean, okay. And then we call loop again. So now it should be like wait. Must be an expression. Okay, well, I'll just return this, whatever. Oh, what happened now? It's taking a while. Okay, we're not set placeholder too. Well, it just reminded me because there's like a scorpion-based enemy, that has an eye that shoots not lasers, but it shoots fireballs. I think. Or is it that you have to have fire? You have to kill it with fire, basically. What's happening now? Man, this is not good for Haskell. Oh. Maybe it was me who... Up to date. How can you get like read IO? What is read IO? Signals parse failure instead of terminating program. Okay. Well, I don't want to get line, that's the thing. Like, how do you get char and make it actually, like, do the thing? Okay, so Haskell force evaluation. DeepSec. I don't know if this is the thing. Why does it need 2 arguments? Control DeepSec provides an overload function. Forcing characters or file to be read. Get contents. Okay, let's do this. I think it's because we never use this. I think that's might be the issue. So let's do like let's do like C deepsec return. Deepsec, where is that? Control. Oh, it's a library. Well, I think it will kind of fix itself if we introduce a state, maybe. So let's do that. So let's make a state because we need a state to know where to put the character. This is kind of where Haskell, you know, functioning programming language, or Haskell in particular, it's kind of like before you actually make the whole program complete. Sometimes it feels like that. You have to make the whole program before you can actually see the result. Sometimes. Okay, so data. What's inline? Okay, whatever. So this is like how you define a new data type. So let's say that this is like the game state, and here's the data. So wait, how did you do this again? Yeah, so this could be like either different states. We can have. Wait, how did you do this? I need to actually look at the syntax here. So Haskell data syntax or something type. Data type. Okay. Yeah, there's also a thing like records and stuff. Yeah, there we go. So this here you can define sort of like a struct here. So let's do that. All right. So we'll have like, and also the kind of the formatting in Haskell is like, it's fine, but it's I think when you do like lists and sequences of things, it sometimes it looks a bit weird with the formatting. But let's just do this here. I think you actually need. It's because of the. It's also because of the indentation type. So I think basically this is usually maybe how they do it. Yeah, it looked a bit weird here, but and then deriving can be like this. Okay, so let's have a state. So we'll have like position is the position of the player, I guess. We should probably have like a player data type or something. And I think you can just have a tuple here actually, but let's actually have like a, let's say vector. So let's create a vector is equal to a tuple of 2 ints. So new type is kind of like a type alias, but you can also treat this as a unique type, the vector. Okay, position. Okay, let's start there. Why is the syntax all weird? No, maybe it's not. No, wait. This needs to have a name. There we go. And then I think, yeah, we'll do it like this. All right. So now all of these functions, I want to have a type that that is those functions. So I think you need like data, and then this is gonna be you know, I don't know, game whatever thing, and then you have the result. No. Let's just start here. Game. This is like, this takes the state and turns it into IO. I think this is like a new type. I'm not sure if you can define, hang on. Can you do, I want to see if you can just define a type alias. I'm pretty sure you can. Oh, type. There we go. Type game equals, okay. So you don't need to have a new type. You can just make type there. There we go. Yes, it does, Blue. Okay, so now we have like a game sort of function, you could say. It's kind of, maybe it's bad to call it game. I don't know. Let's just call it game function, because game kind of implies that it's like it's like data or something. So here we have the state. So now all of these functions accept the state thing, and we also have to provide the state here. And actually, now comes the magic here. So how do we produce a new state? Well, input will have to sort of return a state. So actually, we do need to have a result here. Input returns a new state. Yeah. And so at first I just want to return this state here, just to whatever, make it work. But then, right, so now we have the state available. Now we can say state position. So basically, I think all of these are actually now functions. So you can say position and then on some state to get the position of the state. So, for example, here we can say, well, for one, I actually want to change the type. Whatever. Actually, we could just uncurry this. We uncurry that and then give it position S. So yeah, I'm not gonna go into what that does. Okay. Unless someone really wants me to. Okay, yeah, and loop. Right, so now we get a new state from the input, and we can provide this into the next loop. So this loop will get a state. So from the start, we will just give it like, you know, the default state or initial state, which we need to define as well. This is a state, and then we define it like this, I think. So position is gonna be, well, let's just say 5.5 or 6.6, or I don't know. And yeah, that's fine. So that's the initial state. We're gonna call first loop with this initial state. Loop is gonna draw it. We're gonna call it with S. S is gonna return a new state. And next time we, you know, call loop, we're gonna be using the new state. So that's how that works. And but we don't really produce a new state yet here. So we actually need to look at C to determine whether or not we're gonna switch, we're gonna like move the position. So I'm gonna use like the traditional way is to use the key, the whatever, the keypads. So what I'm gonna do is when we get C, I want to you know what? Let's do this. Let's add a thing to here, because I want to be able to display whatever character we're currently pressing, so I can make some decisions on that. So let's say that C for character, so that is gonna be the char, and we'll start with I don't know, 0 or something. Actually, I'm gonna make this into an integer because I want to have the integer representation of what I'm pressing. Oh yeah, this needs to be C. There we go. Now this is gonna produce a new state, so let new state equals state, and let me just fix this up a little bit, and then position is gonna be let's just use the old position for now, and then C is gonna be this is gonna be like char, no wait, no, this is gonna be ord of C, I think, and we need ord. Okay, so that takes that takes this character, which is like it's just a byte, and turns it into an integer type for Haskell. So we can actually, see what it is, and then in draw, I want to actually draw this. So let's draw this at the top here. So we'll say put string, and what is this gonna be? This is gonna be the state, so this is gonna be C. Probably like a bad name for this, I don't know. CS, that will grab that out, believe, from S. Okay. And show it, except this is an int, so we have to also do show. There we go. Now Blue, you can stop me anytime you want if you have any questions here. Maybe this was too much of like a basic thing, I don't know. Alright, so here we go. So now I'm not sure about the syntax here because it was a long time ago since I did this. Okay, so apparently this doesn't work. Maybe we have to now do... I'll just put everything in one line. Fine. Are you happy with that? You seem to be, okay. Okay, so it still doesn't want to play here. How to take keyboard inputs? Yeah, so that's what I'm trying to do here. I'm using this get char, which is like a built-in sort of, well, it's part of the prelude, which is like always included when you use Haskell, depending on, I guess, what flavor you're using. But basically, you get all these built-in functions like put string is like put str is like print the string. So that's you already have this. Uncurry is also one. Put char, get char. So there's a whole bunch of these functions that you get like included without having to like import something. But what I'm trying to do is I'm trying to use this get char to get this character, and I'm trying to make it, evaluate, since this is then used here. Oh shit, I'm not. I have to return the new state. There we go. Because in Haskell, everything is like lazily evaluated. So if you don't use this C, this is not gonna do anything. Like, it's never gonna like, yeah. But I still can't get it to work. So, Okay, let me. So this is the problem you run into when you try to use Haskell. This is the issues that you run into. Haskell read from standard in, flush or something. I don't know. Okay, maybe I should use flush. System IO. Okay, let's try it. I usually also like always import the things that I actually need, because otherwise you don't know what kind of things are getting imported into your scope and could cause like ambiguous things. Okay, so we got flush. Let's do flush over here actually. Flush standard in. I'm not sure if standard in is part of, yeah. Does it come from here? Yes. Illegal operation handle is not open for writing. Oh, okay. Okay, Haskell read from keyboard terminal. Maybe there's another way. So it does use get char and then h ready. Okay. So get key chars. So this is a monad thing, and so we get the char. We check if there are more. If there are more, okay. So this basically flushes here, or yeah, okay, and then yeah. So we get a string. So we get whatever string is in the buffer, I guess. All right. See you on Twitch. Yeah, okay, that makes sense. But then it's reversed because we want to have the first happen first, I guess. Yeah. Yes. Okay. So let's copy that. Yo yo yo. And let's put that in the library. All right, so you might wonder what this is, but I'm not gonna get into that right now. There's too much stuff. Well, if you really want, I can get into like monads and stuff if you want. But let's okay, so get key. We should also expose. So get key. So now we don't care about this. All right, so we should go to like get key now. Now this is actually this is like keys. So now this is like, now we get like a sequence of keys potentially that we need to evaluate in turn. So I think what we need to do is we need to store those here as a string, and or actually maybe they should be bytes, but this gets a char though. No, it should be fine. Yeah, let's just make we'll have this as a string. This is like the buffer, because we do want to like draw everything happening if you press several keys at once, basically. So we get the keys. We should now evaluate the key, the first key. So basically, yeah, so we're gonna have like the new state is actually gonna be like evaluate input, and then this is gonna be like the first of the keys. But we only want to do this if the keys, if we actually have any keys in here. Also, we could have keys from previous buffers. So I'll make a new key like buffered keys. This is gonna be the keys. Oh shit, now we got shadowing here. Okay, this is like new keys or in keys. I'll call this in keys. So we'll get keys from S. That is gonna be the old ones, and then we append the new ones here. It's like a queue. We get more into the buffer. Okay, and then we get like the new state is gonna be like if the buffered keys, if the length of that is 0, then we just return we just return S. Otherwise, we want to evaluate key with the state S, and the key is going to be buffered keys, and there's a thing called head that reads the first one of there. What you also could do is use like safe head, I think, which will return like an optional character, but let's do it like this for now. Okay, so that is the new state there. Now we need this function here, evaluate key. So this takes a state and a car and then a new state. S character and then returns a new state. So all right. Yes. So this is, so now we need to figure out what to do with this. So now I think the only thing we do at this point is that we create a new state. Position is going to be the same. C is going to be ord C. That's the int there. And then keys. Yeah, so keys will be, so we assume that there are always one there. So keys is actually going to be like the tail of the keys of the old state. There we go. Can you explain state, arrow, char, arrow state? Yes. So this is a type definition. And it's a function that takes two arguments, state and char, and returns this type, the state, a new state. And there's a reason why it kind of looks like a flat list. And that is because in Haskell, all functions are what's called curried functions. And so all functions are actually just take one function. All functions take one parameter only. So this is actually, this is kind of like evaluated like this. First you have you have a function. Okay, it's evaluated like this. Or this is kind of like what it's actually here. It's a function that takes a state and returns this. Which is a function that takes a char and returns a state. So in effect, when you call this function here, like evaluate key, s, you can actually just call it like this, and you get a new function out. But since the syntax is kind of like this, it doesn't look like it's more functions. It's actually like it's a one function that returns another function that takes a C and then returns the final thing. So it kind of looks like one function that takes two arguments, but it's actually one it's a function that takes one argument and returns a function that takes another argument, and so on. And that is very cool, because then you can do partial application and store the result somewhere else. So you can have like, yeah, you can say let f equals evaluate key s. So now you don't need to like pass f in, or I mean s in the function. You could just use f if like this. So that can be very handy in certain situations. Okay, what you just wrote there is composing two functions. So let's say you have a function add, so add x, y equals x plus y, right? But then you have another function called multiply x, y, x times y. But then you want to make a function that okay, actually let's just take one, let's just do this, add 5 multiplied by 2. Let's make it simpler here. So this is add 5, this is multiplied by 2. Okay, very simple. Functions take one argument, returns an integer. Now if you wanna, you can make a new function that does both of those things by saying that add and, so add 5 and multiply 2 is equal to add multiply 2 add 5. So the dot here is the compose function, and the compose function is basically just is defined like this. You take one function, let's just do this for simplicity. One function and then another function, and then it returns another function. It's actually defined a little bit different here. But this one takes f and g, and then does what you're doing there. It applies f on g. Also we take also we need like we return this function. So basically we take these two functions and we return the final function. Actually we do this. So we take an x, that is the a, and put it there. So this is basically what it's doing. Is first it's applying g, and then it's applying f. So this is what it's doing. So add 5 is g, multiply 2 is f. So add 5 is applied first, and then multiply by 2. If you want to, for example, just have like x equals add 5 multiply 2 on, I don't know, 2 or something, 3 or whatever. But actually this is defined a little bit different. So this is actually defined like this. So if you have like a to b, and then you have actually no, it's b to a first, and then a, just to confuse things, because g is applied first, and then so this is actually a to b, and then this is b to c, and then you get a function that goes from a to c. Because g takes the a here, turns it into a b, and then the product of this is a b, so f gets the b and then produces the c, and then you get the c out the end. So that's how the compose works. And I mean, I think I'm using it like a little bit sparingly, because I know it's like, it's really good in some situations, but sometimes it just can be very confusing too, especially if you have functions that take multiple arguments. Then my brain just gets like, okay, what the hell, how do I actually do this? But yeah, it's very useful in certain situations, and it's like, it's kind of like the core of Haskell in a way, because of the composing things. I think it's like one of the things in what is it, in lambda theory, basically, like the thing that kind of Haskell is like built upon. And then you also have like the category theory that Haskell also is built upon. So it has like, in the category theory, there's a lot of things that has to do with composing functions or composing like operations and stuff. I'm just gonna fetch something, bear with me. Alright. Does everything use stack memory? I mean, Haskell still is, is compiled to machine code, so it still has to use stack and heap, and like, I'm not sure exactly how they do it, but Also, one of the things, like since we're talking about memory, is that all of the of the things basically in Haskell is immutable. So everything is immutable, and in pure code, you cannot have side effects. And that's part of the category that links back to the category theory thing here, is that the thing with monads that comes from category theory, you have this monad here. This is a monad called IO monad. And this is basically where side effects can happen, basically, you could say. That is like, I guess, outside of the program's control, you could say, almost. There's a very weird music I hear outside. Okay, anyway. Hang on, I'm gonna remove that. Let's see. Okay. So, anyway, so basically, the way to have state is how I showed it here, is that you have a state that you pass in first, and then you route that through some function that returns a new state, but it's not a modification of the old state, it's a new object. And basically Haskell just keeps track of all, it's like reference counting all your things basically automatically. So it's like there's no garbage collection or anything like that. Or I mean there is no manual memory management. There's like garbage collection. But you can have things like IO refs to store state in and have like that side effect. But then you have to operate in the IO monad. And maybe embedded system can use Haskell. I would think it's possible, but I wouldn't think it's probably a good fit, because Haskell tends to use like a lot of memory, I guess you could say. Like the thing that I just explained there, it has garbage collection, and it basically ref counts everything, and when something is not needed, it will throw it away automatically. But if you've done things inefficiently or not thinking about it, and it can grow in memory usage. So I mean it's like other programming languages like that as well. You have to be aware of how it works, but I mean, it's like there's a cycle. It doesn't garbage collect all the time, I think, because I've looked at how much memory it uses over time, and it's like kicks in at some point, and then it cleans up from time to time. So it like the memory usage goes like up, and then it goes down, and then it goes up and then down, and back up and down all the time. Because the garbage collection system like cleans things that are not used anymore. But it's fine, it's fine as long as it doesn't grow too much, and as long as it doesn't impact performance too much, then it's fine. And what you get out of it, it depends on your use case. It depends on what kind of program you want to make. If you want to make something that's super, super efficient in memory and performance, you probably want to use something else. But it's fine for making games that are, I've seen it also being used to make like, 3D games a long time ago. So it felt like, okay, well, it is very efficient. It's just that it's like, if you need even more performance, you can use something else. Okay, well, let's see. Where are we standing here? So what did we do here? Oh yeah, we're trying out our new thing here. So parse error input else. Okay, maybe like this. No. Is it like a then? Okay, here we go. So I think you can do this. No? Does it have to be like after the if? This is also a little bit tricky sometimes to get the indentation, to get used to how the indentation works. Okay, length is not a thing. Maybe it's like length. Yeah. Alright, we don't do this. Oh, we got warnings. Missing fields. Really? Position C. Okay, this one is missing here. Okay. Keys. It's still not like doing anything until I press. Okay, let's see. So we get the keys in here. We got the buffered keys is the old keys plus the new keys. If the length of buffered keys is 0, we don't do anything. If we have at least one buffered key, we pass it in here. Oh, we don't pass in the new keys. Right. Actually, yeah, so let's do that. Let's do like tail buffered key. So this is actually the new. We need to get the new keys actually. So we can't just use the old keys. We have to like pass in this here. Let's just call this K. There we go. Sometimes it's faster to just look at, okay, there's the error, and then not read the message, but just go and see, okay, what's happening. Could I match char with string in the third argument? Evaluate key, name it tail, buffer keys, state, string. Oh yeah, I kept this thing, okay. Keys at the end, there we go. Okay, it doesn't actually write anything. Do I have to flush the standard out? Like after draw, we flush standard out. Oh, system. Wait, what's it called? System IO. This. And also, it doesn't flush until I press return. It feels like a terminal setting or something. Like or a process setting or. Terminal. Not rushing onto enter. Pink term is basically between one time things. How to make the information? I'm sure I don't understand anything else now. Okay, maybe we need to actually read the keyboard then. Hang on. Okay, so Haskell H flush. Set buffering. Block buffering, line buffering. What is this for reading maybe only? No, reads and writes. No buffering. I mean, what if we just set no buffering? So like set buffering, standard in, no buffering. There we go. Oh my god, finally. Alright, so now on a map, I have these keys here. And I want to map those to the different positions. So we have like 7, 8, 7 is 55, 8 is 56, 9 is 57. So let's start here, like 48. I mean, this is just the numbers, I think. So we start at 41. 49 is 1, and so on. Okay. So 49 is 1. Okay, cool. So let's make a function that is like map char to position. So basically key to position, which is gonna be a vector equals. And basically we can just no, you okay, so in Haskell also, which is kind of cool, you can do pattern matching straight here. So you can do like char. Wait, can you do char like this? You have to have a gourd, I think, for that. What am I making? I'm making like an old school roguelike. I'm trying to make this at character move around the terminal. And if I press a button, I wanna map that to a you know, I wanna add the position to this delta. I wanna, so basically if you press 1, for example, which is 49. So I'm gonna do this just to show here, char 49. Then this will correspond to I guess 1, no, -1, 1. So like to the left and then down 1. But I don't think you can sort of do it like that. I think you have to have like a gourd. Hang on. You can also do like cases and stuff. Haskell expressions and pattern matching. So pattern matching works here. Yeah, you can pattern match. Okay, so you can have like values, but can you call functions? I mean, it is a pure function. I guess we'll find out. So let's do that. I'm not sure if this will work. Okay, so 50 is 2, so that should be straight down. Okay, let's just see if this works. And then I'll do like, the rest will just be 0, 0. Okay, so given that we have this function here, we want to do now evaluate key. So if the key changes the position somehow, we can take this position, the old position, and then add key to position on the character that we get in. However, we're probably gonna get an error now saying that there's no instance for num vector, which is using this plus. Now this, if you're using Rust, this is kind of like how Rust works. This is like a trait, except it's called a type class in Haskell. And so what we can do is we can say instance num vector, and we will define some things. So I need to go and look what we actually need to define here. So Haskell num, no. Now let's see, instances. Yeah, let's just look at one of these. Wait. num int. So we have like plus, minus, negate, multiply, absolute, sign, signum from integer. Yeah, I'll just copy this. There's probably some kind of built-in way to do this already, but whatever. So yeah, so this will be like x plus y equals, yeah. So I think we'll do like ax ay plus bx by is equal to ax plus bx, and ay plus by. I'm not sure if this is how it works. Actually, this needs to be where. There we go. Now it works. And same thing here. Ax ay, bx by, and then this is ax minus bx ay minus by. Whoops. Negate of x and y is equal to negate x negate y. So we're using the built-in to negate and plus and minus on these, because it knows how to do the these things have a num instance already, but now we're defining num instance on the vector. And so we can reuse the num instance for the elements, and really we could actually just say that this works for any tuple with two num instances, but I'm not gonna do that. I'm just gonna do this for now. So we got ax ay times a bx by is equal to ax times bx ay times by. Be careful not to do any mistakes here. Abs x and y equals abs x abs y signum no, this is just equal. Actually, this is kind of weird. What does this mean actually? Is vector a number? Oh no. Is debugging harder than Haskell? It is I mean, I would say it's kind of similar actually. There's a debugger, you can walk through everything that's happening. You can also add traces to like logs of where things, like you can very easily add like logs of like debug logs, and so I would say sometimes it can be tricky in general with like functional programming, because just of the nature that a function calls another function, which calls another function and another generic function, and you know, there's just this deep hierarchy of things happening. But that's why you would need, it's good to have these like traces and stuff. So yeah, I would say it's probably yeah. it can be tricky sometimes. How would this work? Because this should produce like a number. I'll just do some bullshit here. I'll just do like signum x, signum y, and then wait, does it produce a number? Hang on. Signum. It produces. It takes one number, produces the same number. Okay, okay. So then we're fine. Then we're fine. We can do this. Yeah. From integer I. So from integer, it takes an integer. It's the same. It's the same thing. Yeah. Okay. So now we have an instance of our vector type, which we can now use, you know, ordinary math, arithmetic, on this vector. So now there shouldn't be a problem with actually using this plus here. Hopefully. Okay, parse error on input equals. Okay. Why is it like on the second one though? So we got ax comma ay, bx comma by. Maybe this needs to be like this. No. Why is there a parse error here? That is strange. Let me go back and look at oh, is there no... Oh, there's no... okay. There's no curly brackets there. That was my thing. Okay. There we go. Illegal instance declaration for non-vector. All instance types must be in the form where T is not a synonym. Use type synonym instance if you want to disable this. No instance. Okay, this is where the type system is, yeah, tricking type synonym instances, illegal instances. Okay, now you can do this, so it will be like, wait, I think it's like this, and something or other. Whoops. What the hell is it called? Pragnus or... yeah, I think it's like language. Okay, we need oops, flexible instances. This is where my knowledge basically breaks down here with these pragmas. This is it's just. I was like, well, couldn't you do this? And then it's like, no. Okay, equations for key to position have different numbers of arguments. Main 59. Okay, that solved the problem, I think. The equations are different number of arguments. Does it? Okay, you know what? Let's just do like an if else. So you can do like if char no. We'll have to do like a case. C. Okay, can you do that? No, I think that's the same thing actually. No. We have to do like if C is equal to this, then we do something. Is C equal to this, we do something else. Whoops. Yeah. Oh wait. No, let's use guards. Otherwise 0, 0. I think this might be. No, it has to be like this, I think. Maybe? Or? Oh, I see. This is not arrow, this is equal now. Okay. Yeah, it's sometimes I feel like this syntax is a little bit like inconsistent, but there are synonyms. Synonyms for what? Variable not in scope. Okay. Char. There we go. So now if I move, okay. It works, except it's like the other way around. This should be like, that's weird though. How is this the other way around? I get, yeah, top left is 0, 0 or 1, 1. So to move left, is that -1? I'm confused. Okay, well, it works now, so. Yeah. And then we get some weird behavior when we're at the end. So actually, we need to do like max. Let's do like 0 is a vector. 0, 0. We are going to say minimum, no, max 0 or that. So it can't be more than 0. But now I think we need another instance. which is the ordered. No, okay, that's, I guess that's fine. No, it just doesn't work. Okay. Are all ordinal numbers? If you move left, subtracts right. But okay, let's say we start at the top, start at 5, 5, right? We add -1. That means we subtract 1. Right? But here we're adding 1. Unless it's the other way around. Oh yeah, this is the other way around. This is like row and column. Okay, this is the other way around. It's row and column, not column row. These terminal people, man, they have it backwards. Where's the thing? Oh yeah, it's the set cursor position. So actually, this is not like X, Y. This is Y, and that is X. There we go. I think that was the problem, because this actually moved me horizontally, which it shouldn't do. I think that was the issue. This was flipped, because when I pressed 2, which would be down, it moved me horizontally. So now it should be correct. Let's see if we can run this now. If I press 2, we go down. 1, we go down left. Okay, cool. Yeah, so that was the issue. But why is this not working? Max 0. Oh no, because it's the other thing. No, but okay, it works now. It works for 0, 0, but it doesn't work for the maximum position. So what we need is a way to get the screen size. You could use a half block symbol to draw stuff, because you can paint background characters that acts 2 pixels together. Oh, cool. Yeah, I'll take a look at that. So what's happening here? Clear the screen, move the cursor. Ask for position. Like if you could do this, why this should be like inherently known, right? That where the size is. Like why is that not a thing that you can get? Okay, and and this would get cursor position, so that would actually be put in the standard in. I'm just gonna see here, get terminal size. Now here's a package for that. I just data window, okay. So size. Host size. So there's a whole thing here. Oh, here we go. Size. FD size 1. Alright, see you later. I mean, we could just use this package, I guess. It seems more of a hassle to do this. Okay, so now comes the next question. How do we install this now with Cabal? So Haskell Cabal install package. Here we go. Haskell wiki. No? What? Great. You don't. All right. So we edit the Cabal file and add a thing, and then okay, fine, sure. Terminal size 3. Okay. Depends. This is kind of funny because I was like, the Cabal file is kind of like a mix between YAML and some like their own like thing, and I was like, okay, so how do I actually add a new entry into the list? And then I searched for the Cabal syntax, and then there's like a library for working with Cabal files, a syntax. Okay, I guess it's like reading and manipulating Cabal file format, sure. But it's just funny that it's just, yeah, it's just not intuitive on what you actually should do. Wait. What the hell is this? Cabal build depends list. I just want an example. Okay, so you have like a comma at the end, and then you can put the, okay. Oh, here, I guess we had one here, whatever. But I want it at the new line. So this is terminal size. And then cabal build. All right. I mean, when you know how to do it, it's like, yeah, it works. But it's always the case that you have to look things up. You have to, yeah. Okay. So now we have that. Now we can go to my lib. And now we need to find out how to import this. This is also one of the things you have to like, okay, so system console terminal size. So you import this. And then we look at the example. We can just call size and we get a maybe, which has it could have value or it could not have a value. It's like an optional that has a window with height and width. Cool. So yeah, let's grab this size, and I will just, I guess I'll just export this. Can I just export it like this? And also, will it clear my screen when I do it? I'm hoping it doesn't. No, it doesn't. It doesn't need to clear the screen. Okay, so let's just get the size. No, let's just get it every time. So new size. Yeah, it's an IO. Yeah. So we get, now this is a maybe. So we'll put the, this would be like the screen size. Let's make a vector there. So we get the new size. We will also valued key. Yeah, we could also add a size here. I call it Z for size. Screen size equals to Z. And this is now min screen or min Z. There we go. And we might need to shift it by 1. Let's see what's happening. Actually, max 0. This should be like max 1 actually. because it's one index. Okay. And then we get, and then we put the new size, new screen size here, because we actually need to what do we call this? Like we need to map this size. So map screen size, new size. So this takes a maybe window what was it? Maybe window int. I'll just do this. This is how the signature looks. So we will take this maybe. So if it's a just x, this will be, so then you would have like height and width on the window. Actually, you know what? We don't. I'll not do it here. I'll do it here actually. I will move the concept of vectors there actually. Yeah. There we go. And move it. And you take a vector instead. Actually, that makes just like this. No. Yeah, okay. Yeah, now I can do now we can do this. Boom. Okay. Can you rename this? Okay, we'll get this. And if, so basically we'll return like if s, wait, no, case s is a just window, I guess we get a W, and then something happens here, so we have to map the window. Window comes from here, and then we also have like height and width. Actually, probably like this. Okay, so then this just returns like height, no, width of x and height of x. But you actually take, yeah, you take a window, return a vector. There we go. And if we have nothing, yeah, I'll just do like 1, 1. Just add something there. All right. So this would be like get screen size and we also add screen size here. 1, 1. Get screen size. So now we don't need to map it. We can just put it there. All right. Okay. So now we have the screen size, and we can use the screen size to, you know, block off the borders. Oh, so that's not how you do the case, I guess. It's equal, maybe. No. Is it fat arrow? No. What? Do I have to do this? Case. Is it where? No. Okay, 1 second here. Let's go to case. Where is it? Case. Oh, I need to say of. There we go. Illegal is okay. Let's move this over there. What is the problem here? Couldn't match expected window. Oh. Right. Width. Couldn't match int with type A. Right. Somewhere along the lines, we have to like say that this is an actual int. I mean, we could keep it like this to make this like now this is like generic over all integral types. Int is just one of those types. What we can do here though is say that this is supposed to be a window with int, or actually like a maybe. This is a maybe window with int. So now we're saying that yeah, we want it to become an int, and actually we need this scoped type variables for that, so let's add that. Still there's an issue. Couldn't match int with A. What? Okay, let's just try this, I guess. Okay, whatever. Could not load module terminal size, hidden package of that. Perhaps you need to add to the build depends. Well, I have. Did I add it to the wrong thing? What this is terminal size. I guess I'll add it to both then. I thought I only needed to add it to the library because the library was the one that used it. And it would kind of hang along. Not in scope. Vector. Set cursor precision. Oh yeah. Yeah, so now we don't need to uncurry anymore because this is works with vectors. And this one. Alright. So now we can try and run it. And now I can't go past here anymore, except I can wrap around for some reason. Okay. Also, when I press like further to the left, it goes to the top. Okay. So I think this should be like -1. Why does it go to the top? Also, we can remove this now. I can't go more there, but as soon as I go here, so it's like when you go to the left. Let's implement the rest here. So 51 should be 3, so that should be like 1 1. 52 is 4, that goes to the left, so 1 0. 53 is 5, it doesn't do anything. 54 6, we go to the right. 55 is 7, we go to the left, upper left. 56 is 8, we go up. 57 is to the right and up. So now we should have all of those. Now let's see if we can. There we go. Can move around the terminal here. Oh. Okay, it doesn't work flawlessly. Why is that happening? It's like it stops first, but then it continues. So maybe it never worked actually. Okay, what about the bottom? Yeah, I can't move past the bottom here. Oh shit. If I press a lot on the bottom and I try to go up, I have to like move up the same amount. Hello Polaris7, have a nice day. Let's see. All right. One second here. Oh yeah, that's right. Okay. Anyway, it sort of works, but why? Like the new position. Okay, let's actually write the screen size out. So I will set the position to 1, and then I will write out show the screen size of the state. Oh, wait. Now it says 9912. Okay. So it is consistent. So the size is consistent. Okay. So what is happening here? Is this not working correctly here then? Let's also print the position. Yeah, I don't understand. Why does, like, okay. Did I do something wrong here? It should be max 1. Max. You can also do this. You can go to GHCI. So this is like the repo, and then you can like max 5 3, max 1 -1. Oh yeah, because -1 is like special, because it could interpret it as an application of the binary function minus and not like negation. So there's still 1. Okay, so I don't understand then. Did I do something wrong in the... How do you get out? Help! Oh yeah, that's right. You have to put colon quit. Now it's starting to come back to me here a little bit. But why is this not working? Okay, let's look at the... Did I do something wrong in this number instance here? So we got ax plus ax ay bx by ax plus bx ay plus by ax ay bx by ax minus bx ay minus by negate x and y. We just call on that ax ay times bx by ax times bx ay times by absolute. We just spread it there. Signum, same thing. From integer, yeah. I don't see any issues with that. It might be that ORD is already implemented for tuples. So if, yeah, I'll change this to a new type. But that means we have to do this, but also, I think we need to do this as well. Do we have to, or can we do that? Yeah. We have to do this. Alright. EQ. Sounds like vector ax ay equals vector bx by is equal to so this should be a boolean, so it should be like ax equals bx and ay equals by. Now we need show. Actually, we could just, couldn't we do this? There we go. Alright, there we go. What's this? Static construction. Oh, okay. What? I am confused. What? Okay. Haskell, new type. New type, and there's a constructor there. Identity A, deriving. Okay, so show me how. Any. Oh, that's a data. Okay, foo3 is a foo3 int. Foo3. Data constructor, none is scope. What? Wait, do I need to export like this? Okay. Where's this? Okay, here we go. Ord vector. Okay. Can you derive ord? Can you derive like num and ord? Num is not as okay. What about ord? You can. There we go. Okay, cool. Well, it still does that. It still goes up. Okay. Okay, let's not derive ord. Let's define our own ord. I guess the problem is ord doesn't really operate. Well, yeah, ord doesn't operate like on components in the vector. It operates like on all of them. Yeah, that's the issue. So we actually need to like have our own max and min here. So let's just do like vmax takes two vectors and returns another vector. No, but that's what max is doing also. Yeah, it returns the same number. So actually maybe we could implement this here. Minimal, so compare is the one we need to do. But max takes, if this is, yeah, it just returns the entire thing. This is not what we want to do. We want to do it like component wise. So actually we do need to make our own instance here. Oops. Ord vector. Forget about this. So we can implement compare. So A and B. So this would be like, you know, vector. Actually, this doesn't make sense either. No, okay, whatever. Let's just do like vmax takes two vectors and returns a vector. This takes v and u. No, it takes like vector ax bx, no, ay, and then bx by, and then we return a new vector where we have ax is, actually we call max on ax and a bx, and then max on ay by. That's what I want. And then we do min, which calls min instead. There we go. V max V min. Alright, so let's go back here. I will import V max V min. And we'll search for this and use these ones instead. There we go. Alright, there we go. Now we can't go past here and there and there, and we can go all the way over there. Cool. Now I'm pretty annoyed by this cursor here. I think I want to set it to, I mean, I guess you could, maybe you could hide it. I don't know. I don't know if, is that a thing? Hide cursor. Okay, so it's like this question mark 25L. Okay, hides the cursor. All right, let's do that. The lib hide cursor. It's gonna be put string CSI question mark 25L. I guess we can have show as well, which was 25H. There we go. Now we can import that, hide cursor. So we hide the cursor. I think it doesn't really restore it after. So I don't know. Yeah, I guess we'll just show it when we exit. And we'll hide it at the start. There we go. Oh, but the cleanup never happens. Okay. Let's do like Haskell signal handling. What the hell? Handling signals. Install handler. Unix. Okay, Unix to I'll just add it to both here. And so install handler. Yeah, let's figure it out. I wish I just wish they had like examples, but what was it? System signals. Was it handle or handler? No, it's handler, of course. So it takes a signal, a handler, and maybe a signal set, and then returns an IO handler. Okay, so what is a signal? Yeah, this one. And then the wait. Yeah, now we need a handler. So we need to pass a thing that is a handler. So either default, ignore, catch, catch once, catch info, catch once, and then you provide this, which I guess is the handler that you want to then use. So we'll do catch once. We don't need to do anything else, and then it's like interrupt handler or signal handler, or I just call this like quit, and then we'll have a quit thing that does this. And then the last thing was the maybe IO set, signal set. Handler ISIL call sig action install set is just as the mask sig action. What is this? False reserved. Okay, I guess I'll just do nothing on that one. And then this potentially returns like the previous handler, but we don't care about that. All right. Just needs to install these things. And build them and everything. Okay, here we go. Legacy fallback. Let's hope everything works. I mean, I wonder if that works for... Because, I mean, yeah, I think Windows also has handlers, but I don't remember if how different it is. I know that there's like signals that exist in one place and not in the other. Catch once. Oh yeah, this. Okay, so this would be handler. Okay, so if I do Control C now, it should quit, please. Okay, why didn't it quit? Hello, Vicent. Building Unix, yeah. Yo, Blue, welcome back. Is it? Ah, maybe it's because it's still in the loop. Oh, man. So we need this to... Wait, how does... Okay. I mean, I guess we could call, like, there should be a way to call the exit syscall here. So Haskell process exit, system exit, exit with exit success. Base. This is in base. System exit. System exit. Exit success. Why isn't it exiting? Do I need to like force this? Is this because of the lazy evaluation or something? Like it doesn't exit immediately? Should be called from the main program thread in order to exit the program. When called from another thread, we call an exit code. What counts? The interrupts. What does those count as? The signal handlers run in main thread. I guess it depends on. It doesn't work. I guess you could technically have an IO ref. Yeah. As I said down here, you could have an IO ref that says that you should quit now. And write to that, yeah. Like they're doing here, yeah. So we have an IO ref that we pass in. Because the problem is that the handler only works in the IO monad. So we have to like. So this is like should quit IO should quit ref. It's like a new IO ref or something like that. False. Should quit IO ref. So now that is our IO ref. We can pass that into our. No, wait, this should be over here. Yeah, the only thing here is actually we just need to write IO ref should quit ref true. Okay, and then we have to pass that into the loop. So should quit ref. Now the loop. Yeah, it takes an IO ref of bool. And actually, the first thing we need to do is we need to say if should quit. No, should quit. So first we read the should quit. Read IO ref should quit ref. Then we're checking like if should quit. Then return nothing. No wait, this is the input. What the hell? The loop. There we go. All right. If we should quit, we just return nothing. Otherwise, we do this. Okay. So IO refs are basically state that you can use within the IO monad. So we can use that now to have like a global almost here, you could say. It's not really a global. It's more like it's a local within main, I guess you could say. So it's sort of global. Yeah, but yeah. Let's see if it complains now. And we don't really need to exit success anymore there, because it's gonna do that anyway. Alright, so now we need the IO refs. And that is in data IO ref. And we need IO ref, new IO ref, write IO ref, read IO ref. Should quit ref. Yeah, that's the other way around, I think. There we go. And we'll pass that in there. There we go. And now we... Okay. Well, it didn't like quit immediately. I had to like press a button for some reason. But it does restore the cursor, at least. Why do I have to press a button? Is it because... Maybe we'll flash... Anyway, okay, it doesn't really matter. I'm not gonna fix it right now. It's just yeah. Anyway, okay, so now we got our little dude going around, little thing going around here. You can move around, and it shows like the position and the size of the map here. Loop is waiting on input. Yeah, I was curious because the loop, for the first thing it does, it checks if it should quit. So if it should quit, then it doesn't do anything else. But there might be a blocking read or something in the way. I don't know. Maybe it's because when we interrupt, we're actually over here. Yeah. And we're blocking. Okay. So I think in order to fix that, we have to use like non-blocking input. Which we could. I think. Actually, yeah. Spawn process. No buffering. Yeah, I already set no buffering. Blocking? Oh, this is no blocking, okay. Fork, get line. Yeah, this is all very interesting. I'm not gonna do that right now. Well, what can we do? What can we do more here? So we got a little. So basically, if you want to add more things here, we could add more things to the state. I was thinking. What did you say before, Blue? You had like. Read with eye referencing. Yeah, the problem is, I think, is like when we call. So basically, actually, I guess you could spin up another thread and read in that thread, and this would kind of then kill that thread from the main thread or something like that. When you get when you get this, you would kill this. You would kill the input thread, because then you would kind of make it non-blocking. Add a timeout. I think that the problem is that get key here. This is get key. you know, the problem is that this get char is using, you know, I think it's using like the syscall to actually read from standard in. But the problem is that there's like different versions and it's using the version that is blocking. I'm pretty sure that's the problem here. I'm pretty sure there's like a version that is non-blocking. No, not. Is it read to? Maybe it depends on the file descriptor. The read would block. The file descriptor. This is like, yeah. So if you try to read on something that is non-blocking, you get E again, which is like, yeah, try again, basically. Okay, so it depends on the file descriptor. Okay. So how? So okay, so standard in read non-blocking. You can only read a character at a time. What? There's no way to get read line to work. Oh, I see, I see. Okay, well, anyway. It doesn't matter that much. It's just for the there's not gonna be like real time stuff happening. It's gonna be like turn based. So it doesn't really matter that much. It's just for that ending thing. Like we're stuck here. When we press Ctrl C, we're still stuck here. So it won't check until we're up here. Actually, you know what? What the hell? What am I saying? There's a thing here. Ready. Why are we doing this first? We should check this first. As if this is false, we should just return an empty. Yeah. If ready, then we do all this crap. Else, we return empty. This should do it, right? Oh, but now comes the problem of this flickering here. Okay, but now if we Control C, okay. Maybe we can return from input. We can return like, hey, something happened or nothing happened, basically. So we return, we pair this with a bool, and this would be like, actually, yeah, this would be like false, and this is true. So nothing happened here. We return this with false. Here something happened, we return it with true. Okay, so then we get the input here. We get the state, something happened, was updated. Actually, you know what? Let's add this here, was updated. But this, I don't know if there's a way to like automatically copy everything. Whoops. I know there's things like lenses and stuff, but I won't get into that here. It would be incredibly useful here though. C equal to CS, keys equal to keys S, screen size equal to screen size S, and then was updated equals to false. And here we just say true because we got something, some key press here. And then here we say like if, so there's a thing called when was updated S. So if we were updated, we do this. Okay. What? Control monad. Oh yeah, now this is back to normal. Okay, there we go. There we go. Cool. Okay. We got a somewhat stable system there. All right. Yeah. So yeah. So now what? We could try and add color, so we could draw or yeah, print the dude with some color. So where is, so we need to find the color stuff. Color stuff. Okay, CSINM. So lowercase m. All right. Reset or normal. So I guess you would want to start with that if you want, maybe. Alright, so reset style. CSI plus M. That was the only thing we need. I'll do like 0 M. M is more efficient, but whatever. So then we have like, oops, bold, which is 1M. Faint. Italic. Underline. Slow blink. Man, there's a lot of weird stuff here. Rapid blink. Yeah, that's the next step. Writing a paper. Reverse video or invert. Swap. Foreground, background colors, inconsistent emulation. I'm just gonna call this swap. That's gonna be implied, conceal or hide, crossed out or strike. Okay, set foreground color. So this would, we would need an integer here. So it starts at 30 and goes to 37. So it would basically be like this plus, I guess, C for color. And then we would do show. And then we have like background is 40. Oops, the 7 is not supposed to be there. All right. There's a whole bunch of weird things here. Okay. But that should be good. Right. Now we have to all the style stuff. Style. Wasn't that a thing? Reset style, or is it reset style? No, let's do like style reset. Bold, faint, underline, italic, slow blink, rapid blink, swap. All right. Just see if that builds. No. So probably because of this. Okay. What is happening here? Couldn't match. Show. Oh. Whoops. Okay, it compiles. Now let's test it. So the character. What color do we want the character to be? Let's do style foreground 0, and then we reset that. Oh, it's barely visible. It's actually, it is visible, but yeah, okay, that was something. What is 1? That's red. Okay, so let's create things for that. Let's do like, I don't know, black was 0, I think. Red. Maybe there's a table for this, but green. This is how you make your own table. Is that supposed to be yellow? Blue. We could also, let's see, there's a way. We could do like map. Hang on, what was it? I forgot. There's like a combinator. We got like a monad M. It just takes 2 M's. Okay, so M A or M this maybe. Or just this. Control monad, okay. So we can say put char at actually this is mapping that, so we need to do this. This is the color. We get the color in, we produce a monad, and we want to do this on 0 to 7, 8. I don't know if this is inclusive or exclusive. Now we see everyone. Okay. So what? Yellow, blue, purple, cyan, gray. Blue, purple, cyan, gray. Blue, purple, cyan, gray. Purple, cyan, gray. Cool. All right. So now I need to export those. I could probably you probably want to do this in a better way to define these things in some sort of group somehow. Like you could do like data color equals black, red, green, whatever, and then you could like map those to the numbers, and then you don't have to like you can only you can export this whole thing instead, and it will be a bit more, but whatever. So we'll get like, I don't know what color, yellow maybe. So now we can do like yellow. What? Couldn't match. Oh. Right. Okay. Let's get rid of these debug messages. Cool. All right. Okay. So that's, yeah, some basic stuff there. Let's see, what did I want to do? So basically, yeah, so it would be cool also, you know, you could put this in a similar, you could just make like a concept of having it like, I don't know, a character, and you would have like, I don't know, position is a vector, color. Yeah, so we'll start with that. And then you would have like draw character. Character into that. Now you could also, I think here, you could also do this character, and then you get the position and the color like this. Or if you have to say like position equal to whatever, but I'm gonna try that. And then you get the position and the color out. So now we can do style FG color and put char. Oh yeah, we should also have like which character are we gonna put. So I don't know, graphic. Oops. Graphic is a char. So we get the graphic here. Put this there. There we go. And also, and also set first position to the position there. So now instead of doing all this, we can do draw character, and then like, well, we don't really have the player here. We should then change this to a player, which is a character. Yeah. And now we have to change this. This is yellow, and then at. Okay. Now this is changed. This has started to become a bit much. This one is equal to player. No wait, and then position is this. And then the other one's the same. So there's a way to make this more easier, but then we have color is color of player of state, and what was it more? Graphic, that's right. All right. But yeah, so the position is equal to whatever. This needs to be player. Yeah, so definitely when you have a state like this, you should basically you want to look into using lenses instead, because this becomes very if you have to like write out everything like this every time, it's gonna be a hassle. A hassle. All right. Okay, so now we have this character thing. Let's put it up there. Okay, what are you complaining about now? The good thing about Haskell, though, as we need to talk about good things as well, it's like when you compile a program, it just feels like, okay, now it should just work. Now it doesn't always be like that, but what is this? Parser 5. Okay, so we actually need to put this here, I guess. Oh wait, actually it's a vector. No. All right. What? Okay, there's something weird going on here. Oh, did I never did this? Yeah. So you cannot do this apparently. I think you could do this to alias them. Data constructor player. Whoops. Player. No, it's character. Oh. Deriving. Alright. So now we can talk about these characters. Oh, I saw a flash there when it was the normal color. Ah. Okay. It's safer. Which one? Which one? Which what? Sorry, I missed it. Okay, well, great. Should we do lenses, by the way? I forgot. Let's just do it because it's fun. So we got lenses here. We have to include this package. I'll just let that like download and install in the meantime. There we go. And yeah, this is you're greeted with a diagram like this. Great. Yeah, and then there's like, yeah, here's how to like manually do all this crap. There is a way to like what is it? Generate the things with something called like template Haskell. Let's see if I can find this. 4 years ago, people still using lenses, traverse or generic lens, overloaded labels. Okay, whatever. Tutorial. Make lenses. Here we go. So we need like template Haskell. And let's just copy this. It looks a bit weird, but everything looks weird here. Okay, so we need this. I'll put this up there. So we have this import. I don't know what hiding means. Oh, it's hide. I say importing everything except element. Okay, and then template Haskell. So yeah. So here's like a thing. So we have an atom with an element and a point with x and y. Then we're calling this, which is like generating basically Haskell code here. This is like the Rust macros. Kind of. It's like you're producing like. I think it's like that anyway, because you're producing pretty much like a string of Haskell code. And that gets just you know, put in here. So now all of a sudden we have lenses for these things, which means that we now get a point function, which is the same name as this point here. We can call this, we can use the lens library to use this as kind of like a selector on this atom to get the point. But it's basically used so that you don't have to like repeat everything and copy everything. So you can basically just say that, hey, I want to change the point. And you just have to say, I want to change the point, and it's gonna fix everything else for you. And as you can see here, also you can combine it with point.x. So now that means that first we have the point, and then we have the x, and we want to add 1 to that. So what this function is doing is that it takes an atom and adds 1 to the x on that. And that reserves everything else on the atom, so the element is the same, of course. The point, the y is the same, it's just the x that changes here. So this is a very more easy way to actually do these things. But we don't have this atom or point, but I'm gonna keep this, or yeah, I'm gonna put it over here. So we want to make lenses on the state and on the character, and I think it basically forces you to do this. What was C? I don't remember. Oh yeah, C is the character that we're currently reading. I don't think we need that actually. I'm gonna remove that. You have to do this. So it looks a bit weird, but it's way better for using it later. I want to no, let's keep that, sure, why not? Right. Now when you create a state, you can still do this, except now you actually have to do this. Alright, whoops. Alright. I don't know if there's a better way to like initialize a entirely new instance, but okay, we can remove C. Also input, do we set C here? We don't care about C. I'll just remove that for now. And we don't care about C. Okay. So how can we use this now? So evaluate key. Let's make it so that state is at the end, because then we can use the over method that was there. And let's just rewrite this. So first we take the keys, and then the size, and then the state. Actually, let's do that. So then it was like over, and then you have your selector. So this would be like, the thing we want to change is basically the position of the player. So this is gonna be like player dot position, and then there's also things where you can get like the first and second or whatever, but we just want the position here. So the position is gonna be, then we get the position here. We basically wanna do this. Wait. No, we still need C here. Yeah, we still need this. Yeah, we need to know which one we should actually do. Execute. So we take this, Now we could just move that to another function. We could just say that we could say oops. What could we say? Actually, we could do like clamp to map, takes a vector, turns a vector. We do the min-max thing. So now we can reduce this a little bit. Alright, and that's basically all we're doing here. Everything else is copied, so we can just... Oh, and... Well, okay, one more thing is like, was updated true. So we need to do that as well. Position... Oh yeah, so now this is just P there, yeah. Okay, that was way less code. Alright, so now we just need to do was updated true. So I need to look up how to do that. That's also a bit of the issue with lenses, like they have this whole, their own like vocabulary of actually doing stuff to your state. So over, I mean, yeah, we've seen over. How do you actually do like multiple things at the same time without, you know, I could just do, I guess, multiple, another, like make another over and call both functions, I guess. I mean, yeah, okay, so we could do, whoops. Man, I hate it when it does this. Resize. I'm trying to resize my window. What? Okay, I have to do it manually. There we go. All right. Let's see. So we could do like, okay, so update player position maybe, which takes the character input and a state and returns a state. This one will take that there, and we'll basically just do this. Okay, and then we also want to do like update was updated, and we'll take a bool and a state and a state. So update, or basically set was updated, you could call it. And this would be like was updated is just gonna be and there's a built-in called const b, which takes, it's a function that takes an argument, or it returns a function that takes an argument, but it just, the result is just always gonna be b. And there's probably a variant of over that just sets the thing instead of, yeah, but or yeah, but yeah, that should be that. So we want to do both of these things now. Since since we have like a state to a state, we can do both of them like this. So first we update the player position, then we set what's updated. Yeah, so basically now we're doing both of those things. Also you need to be true there. And 93. Also, now that we have lenses, we could take a character and we could do we could probably do like some kind of thing with that. So how do you just read a value? View, okay. So view, you could use that. So we don't need to grab all this. We could just get the character. Here we take view. Position of the character. Here we do like view, view color. And here is view graphic. Oh yeah, we need the size of the map. Clamp to map Z. So actually here we need the size of the map as well. Oh, but we have state. So we could do like view screen size of the state. And also you can do this, so you can do like let screen size or let Z equals to view screen size and do that. And you have to say in. Okay. Actually, we have to update the screen size as well. So over, so just do screen size and const Z. And yeah, there's probably a variant to do this, but yeah, whatever. All right. Yeah, so also update screen, so set screen size. Now we can just add that on. So we do that also. Okay. So we're setting the screen size, we're updating the play position, and we're setting what's updated true. Yeah. So it's a little bit easier to handle all that stuff. Okay, so let's see what's happening now. Player S. Right, so this now we need this to be view player S instead. How does it look? Yeah, I'm trying to get it up and running here. 75 over was updated. Could match state. Oh, right. Remove this. Could match expected value. Same thing here. We don't actually receive state. in there. Variable non-scope S. What? No, 71. Screen size. Oh, right. I mean, we could just get S and then call over on S. You can also do that. Set screen size. What is the issue? Oh yeah, you need to take the screen size in. That's right. There we go. Couldn't match state with. What? Do I need to do this or no? Set screen size. Expected type stated char. Oh, the play position, right. Oh yeah, you need C, that's right. And K is the keys, that's right. We also need to set the keys. Wow, there was more things that I actually didn't see. Set keys. Yeah, it's just the same thing. We set the keys, we get a string. This is the keys, we get const K. We do set keys. Okay. Alright, so we got this here, 59. Right, so whatever we're doing here, actually we're just updating what's updated. So basically we just need to set what's updated to false on the old thing, and that's our new state. Couldn't match. Actually, is that true? Yeah, we're just copying the old thing. Yeah. Well, we could get a new screen size, I guess. No. Okay, what's your issue now? Couldn't match. 57. Alright. Oh yeah, so view keys there. And now we're talking. Okay. Alright, so we are here. I mean, we're basically. I just made it easier in the code to update the state basically with the lenses. Okay, now what do we want to do? Yeah, so now it's like, okay, so what do we want to do now? So basically, yeah, now we can just look at extending the system. Where's the state? So we can add things here. So now it's also more easy to add things here now that we don't have to deal with all that crap. So we can have a player. We can also add, you can add a monster. We can make it into like a maybe, so that if it's something, it's alive. If it's nothing, it's dead. And that's like another character. And then we can start with a monster
that. Let's actually make a function here. Make monster. We'll take a position, a color, and a graphic, and we'll return a character. I'll just call it make character, whatever. So we got position, color, graphic equal to character. Alright. So now we can say make character, and we can basically remove all this. Actually, I think this needs to be like this. So vector 5 5. Let's do like 10 5. Red. And teeth as a troll. Or actually, no, yeah, no, that's fine. Red. Wait, what's your issue? Maybe character. Oh yeah. So this is a maybe character. So I'll just wrap it in a just. Okay. Well, it's not showing up because we're not drawing the monster. So let's go back. Let's go to draw, and we'll draw the monster. Oh. Oh yeah, because it's a maybe. So we could do. Okay, let's see. Is there like a maybe when or something? So basically, like if you have like maybe a, and then an IO, no. Then you have like a, let's see, how would this be like? Yeah, then you have like a function that takes a and returns an IO something. Because it's like, and then, so you get the function and then this is an IO. When is just data maybe. When just maybe M. What does this do? Maybe M. I guess it kind of does what I want it to do. Maybe M. But that looks, this looks part of some kind of a GHC. When is just data may GHC data maybe. Why is it like the GHC? Like there's so many things here. If else, that's a pro. Okay, I guess well I'll test this one maybe. when is just from GHC data maybe. So we'll do when is just. It's also super easy to do your own. I guess that's why there are like hundreds of them. When is just, so this is like view master s. We will do draw character. And that doesn't exist. GHC. All right. Oh, could not resolve dependencies. GHC. Okay. How do I go? Oh, maybe it's just data. Maybe. No. Okay, let's just do our own. It's super easy. So it's just like when it's just. We take a maybe a, and then a function that takes a and an IO and return an IO. And it's just, you know, if we have a just a, and we call this f, we will just call f on a to get the IO. If we have a nothing, we will just return that. Okay, enough of finding a package to just do this. Number of arguments. Yeah, so we don't care about this arguments. Okay, there we go. We got this troll here. Cool. Alright. Now let's add some health to the characters. I don't know about the format here. I'm just doing what works until now. Let's do like health. We'll add health here. I'm pretty sure you could probably. I'm gonna try something here. I'll keep this here. So health. I'm gonna try doing this and then character, and then that should basically be the same thing. I'm pretty sure. Yeah. Okay, so I don't even need this function here. Okay, cool. great. So that's way easier to do that. We could also do that, but it's nice to see the labels though. Okay, so now we got health. Now, how do we check? Now we need some collision detection. But I'm just gonna grab something to drink here and I'll be right back. Alright. Let's see. Okay, so do you have any ideas, Blue, on what we should add here? Actually, you know what? Maybe we should make it like you're shooting. We could play maybe like a shooting animation. Yeah. And during the animation, the input is ignored. Let's see. Let's see if we can shoot. I mean, yeah. Let's just see if we can do like shoot. So from I'll just say like from and to, so we can more easily think about this here. And then this is an IO. Actually, yeah, we could do this. Actually, we could make this into I was thinking more, maybe we do need to update the state in that case. Okay, actually, yeah, let's draw shot. And we need like Okay, I'll just start with one vector, I guess. Okay, this bullet has a position. And I guess it would have like a direction, like velocity or direction, velocity. Alright, let's start there. Let's make lenses. Alright, then we'll have like a list of bullets in the state. So we'll add bullets, and this would be a list of bullets. Also, we probably want... No, okay. We'll start there. And there's no bullets to start with. So how do we aim? I guess we could enter like an aim mode. Like you press space or something, and then you enter the aim mode, and then you press one of these to get where, like, the velocity. Or if you press something else, it like aborts. He's aiming. So if we're aiming, that means we can't move. Position, bullet. Let's do like, I don't know, yellow. And no. Graphic. And the bullet has, no, it has a velocity. I think what I want is, I want like bullet graphic. So we'll take a bullet and whoops, return a character, and we'll basically map so we get the velocity from the bullet. And we'll do like case v of, and we're mapping. So basically, let's say we start at -1, -1. That would be, was it this? That would be a this one. Or 1, 1 is also that one. Or it's -1, 1, that means it's this one. Or it's 1, wait. No, this doesn't make sense. -1, -1 should be down, should be this. And this is up, left, yeah. -1 to 1. So -1 x left and then down is this. Right up, right up. No, that's correct. Wait, I'm thinking about this in several different ways. -1, -1. That's bottom left. Yeah, so this should be correct. 1, 1 is top right. That goes up right. Right? This goes like left, down. Right, down. This should be like this. Right, up. No, this. Yeah. No. No, that's down. Left down, right down, right up, left down, left up. There we go. Okay, there we go. Holy shit. Okay. Man. Let's see. Now we got like to the left. We got to the right. We got up. Or yeah, up and down. Okay. Then we got like otherwise. I don't know, a star. Okay. Oh yeah, game. No. Okay. Cool. Oh, they can't be named position. Oh, shit. This is a little bit of the problem here. The shadowing here doesn't work. We can't have two things that has the position. That's a bit of a problem. Usually you would like prefix, but I just don't like that. But they do end up in like the global sort of scope, so that's what I don't really like either. I wish it was a better scope, but okay. Let's just prefix this with character. I won't prefix that one. Alright, so now we should get a whole bunch of errors everywhere. So this is like character position. No, we don't have bullet graphic. We have bullet graphic. There we go. Oh, velocity. But as long as there's like a nice convention, though, good. Could have matched vector. Yeah, it's complaining, but whatever. All right. So now what? Yeah, so now let's see. We have this bullet thing. We need to. So let's add a bullet. Just adding one here. Let's see. You want a position. So let's do like 6, 5. And velocity is 1, 0. So it goes towards the troll basically. Yeah, we're not showing that though. Why is it complaining? Oh, is aiming, that's right. Okay. So let's draw the bullets. So basically in draw, we will map M draw bullets onto view bullets. Okay, here's our bullet, but it's not moving, so we need to make it move. But if anyone wants me to explain anything, I'll gladly do that. I'm just trying to move this along here. Alright, so we're drawing the bullet. Yeah, so we need to update the bullets. So let's make a function here, update bullets. Basically, we just need a state and a state. So I guess we can do like over bullets on the state, and here we just do like map update bullet. And we need an update bullet now. So this will take a bullet and return a bullet. Bullet B. Actually, we can use lenses here as well. So I mean, yeah, we basically just want to increase position by velocity. However, it will go pretty fast. But let's just do it. No, actually, this would just happen once per turn, I guess. I was like, in my mind, I was trying to think like more like real time. But I think we'll just do turn-based, actually. So so basically, yeah, so just over position or bullet position on that, we will just we'll just add view. Oh yeah, now we actually need a bullet here. So we'll view the bullet velocity. So we're adding position with velocity basically here. that. It's like when you squint and remove all the things around, you kind of see what we're doing here. All right. Well, we're not calling update bullets, so let's do that. Actually, this will be real time because we're doing this every frame now. No, we're only doing it if something updated. Yeah, we're only doing this if the key was pressed. Right. Let's add this here. Update bullets. There we go. The bullet goes chasing the bullet. Oh, couldn't catch it. All right. Cool. Alright, so now we want to check. Basically, as part of update bullets, we probably want to just check if it hit the troll. So we increase. So we're doing this. So this would be like update bullet position. So we'll do that. Then okay, so how would we do this now? We check, well, we can check for if the monster, oh yeah, we need the state actually. We need the whole state here. So we actually need the state, yeah. And also we need to return state. So actually, well, we could update the position and then later we could check. All right, let's do that. Update position. So we'll have like update bullet positions takes that is that. So first we update positions, then we will check bullet collisions or resolve bullet collisions. Right. Actually, couldn't we just say here, we could just say we could just say like bullets. I was thinking if we could like select, if there was a selector in the lens that could select like all of the, or like select the items. Yeah, I don't know. Anyway. Okay, resolve build conditions. What do we do here? Let's just do this a little bit more like this. So we'll get the bullets. That is gonna be the view of bullets from, actually this is state. Alright, so we got the bullets. We want to check if any of them overlap with the troll. So basically maybe we could get like all of them, like, okay, so colliding bullets, that is gonna be filter equals monster position on the on the bullets. Yeah, on bullets. So yeah, and we need the monster position is going to be view monster actually now this is a maybe. So basically, yeah, we could do like case view monster as of if we have the monster, we use it there. If it's nothing, we'll just return S. If we have the monster, we will get the position of the monster. And we'll get all the colliding bullets. Then the monster's health should be, so damage is going to be colliding bullets, is going to be like length of that, and also it's kind of weird, we can't really figure out how to destroy these bullets. I guess they would just go on forever and get stuck in the wall, but whatever, let's fix that later. So so we got damage, and we will return now these, we will do like over, and this is gonna be like the monster. We don't really care about what the monster was. We are going to say actually this could just be over again. No, yes. But this is a maybe, so but we know it exists. Now, okay. So let's say we have this, and we just return the monster. Actually, I don't think this is good. Let's just do M here for monster. So if we just return this, this is basically gonna be like a constant of this. So this overrides it, but except it needs to be just M. But here we can do. Actually, let's just do a new monster here. Yeah, so this would be like over, and then we need like health, and then we do negative damage on M, and that's our new monster. There we go. And then we return this. So we update the state with we update the state. We set the monster to this new monster, which is the same as saying const new monster. All right. So now the bullets can damage the monster. We can actually print the monster health so we can see what's happening here. Let's do put string show new monster character health OS. So this is where lenses are really nice, because you can like combine these to look at the things inside. Way more easier than, you know, the built-in like Haskell way of doing it. Okay, so oh yeah, this is a maybe character. Oh shoot. Let me check. Lens maybe. Underscore just. But are we assuming it's a just? Traverse. Okay, this print process was tweaking the targeted value just in a maybe. Okay, so if you I guess this is saying that if you provide a nothing, it will be nothing. And I guess this just makes everything a nothing, or I don't know. Okay, control lens prism. So yeah, we do just to get rid of that layer of maybe, perhaps. Okay, so how do you do this? Because I don't want to do this, because this... Okay, so in Haskell, basically you have like... I'm not sure what it's called. It's called something, but basically you can provide... If I said something like this, plus damage, this is actually a function that takes something and adds damage to it. So if I said this, it wouldn't be a problem, I don't think. No, there's an error somewhere else. But if I say negative, there's a problem all of a sudden, because it can't differentiate between negative and negation. So like there's like, yeah, the minus has like a special thing here. But if I, and in Haskell you can actually make a binary operation into like a normal function like this. So basically you can say like negative AB, and that is the same as saying A negative B. It's just the syntax of the language makes so you can do it like that. But now, as you can see, we're providing A, which is the first argument, the left argument, and minus, I want to make it the second argument, because otherwise it will be wrong. So I don't remember what this is called. This is like called something, like it's not like partial application. What is it called? It's called something. It's like operator, partial application, infix functions. Yeah, so you can see here is using with this operator, and you can have the argument either on the left side or the right side to say that if you have a binary operation, you can basically choose to provide the left side or the right side. But I would have to write something like this in order to get around this. I was just looking if there was a way to do it for the negative easily. Like plus, there's no problem. You can do this. And anything else, basically. What about negative? Okay. Yeah. Okay, whatever. So I have to do this basically in order to make it work. Fine. 117 bullets. You want something that you can't have. Coded match type A0 const A. Whoa, what the hell is happening here? We're viewing the bullets, so we should get a list of bullets. Oh, let's just call these the B's, actually, to not confuse the compiler. Okay, so better error message this time. It does allow you to shadow things, but that is like, it doesn't really say that, well, wait, this is ambiguous. It just produces some wacko error message. Could have matched bullet with vector. Oh, right. View bullets. Let's do bullets and position. No, hold position. Oh yeah, and this is. Can I do like traverse here then? Like where is this coming from? Traverse. Combinators. Traverse is one of those super generic ones. Wait, so BS should be, that should be like a list of vectors. So if I just do traverse, will that... Oh, wait. No. I should map it. They should be mapped. How do you do that? I wanna basically map it. Look at all these crazy things. Only index. From to second. Yeah, there's so many things in this whole thing. I'm just gonna say let's see. Let's do like map. No, so I want this, but then the result I'm gonna map view position. Yeah, so we'll get the bullets, and then I map this over that. So I basically get the positions now. I should have the positions now. All right. 171. What's going on here? Monoid int arising from use of just. Are you serious? There's no instance of monoid int? Oh my god. Okay. So there's no monad int because int can technically be implemented using different things. So okay. And therefore I can't use just to get this thing out. I have to basically, either I can use a new type, something that implements monoid. I mean, I could just make a monoid int, I guess. No, this is a semi-group int. What the hell? Okay, now it just works. I simply needed to add those lines. This is weird. But okay. We have, just before the monster, yeah, we have a bullet flying around. This is interesting. Like, it just worked, I guess. I thought I had to like implement some functions there, but apparently something made it work anyway. So yeah, basically because the monster is like an optional, so you have to add a just in there to remove that layer of stuff to get to its health there. Okay. Now, yeah, so now I want to do space to add. Space will make you go into aim mode. I mean the space bar. Pressing the space bar. Alright, evaluate key, blah 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 blah. Let's do like update aimed is aiming. Where is this happening? So I think it's like is it 32? If C is equal to 32, or actually this is a char, so we can just do this. Then we are going to do over is aiming s, or yeah, I'll just do that. Over is aiming is const true, else const, or ID. So yeah, if it's space, we go into aiming mode. Otherwise, we don't do anything basically. So let's do this. Let's say that we draw our character. So if is aiming, then I'm just gonna put this out to show that the player is aiming, basically. Else no, this is just when. There we go. When we're aiming, show this. Alright, so I'll move over here. I'll press space. Now we're aiming. Oh, okay, this gave me another idea. If you press, okay, maybe we should just spawn a bullet if we press space that shoots to the right, but then you can't really aim. Oh, but maybe we can make like things coming from, like, yeah, this is perfect for this actually area as well. Like things coming from the right, you try to shoot them. So it's like a shoot 'em up. Yeah. Okay, well, remove this. If we're... So we don't really have this is aiming. Shit. Bullshit. Let's move this. Yeah. Remove this. Yeah. Is aiming. Yeah. Update is aiming. No. But we want to say update spawn bullets. Or bullets. If this, if space is true, if space exists, if space is not fake, we will go over the bullets and we will add a bullet that has position, and the position is gonna be view player position let's do this. If then else. All right. So we'll create a new bullet that has the position. Yeah. Yeah, that's just the position there. Actually, we want to also add one to the right. Yeah. All right. Then, yeah, and the velocity is gonna be like that. Okay, is that all for the bullets? Yeah. All right. Okay. Update is aiming. Update spawn bullets. All right. Yeah. It's like a turn-based shoot 'em up. I mean, there is like Doom RL, so. All right. Now the last thing I'm gonna do here, I'm just gonna make the troll die. Auto aim like Vampire Survivors and Megabon. I've actually never played Vampire Survivors. I have played like a similar game. I think like Brotato or whatever it's called. Yeah. Is it auto aim really? On Vampire Survivors? Oh yeah, I guess it is. You just run around and it's like attacking like the closest one or something like that. I don't know. I never played it. Alright. So we can spawn a bunch of boots. Now, the troll is also, yeah, so we need to have an update for the troll. Or the monster, I guess. And that should happen like... This is kind of like the update systems in my other game. Like when the update for the monster happens after the bullets. The monster will say... the monster will say ouch if it's hit. It will say very much ouch if it dies. If health drops to 0. So if you monster just health is equal to 0, Brotato, yeah. Move and upgrade. I played it frenetically for a while, for like a couple of, I don't know, like a week or something, and then I just, yeah, now I had enough. It's really a nice game, but I don't know. I want to move on to other stuff. I'm not the one that can sit down and play the same game like, you know, forever. But yeah, let's see. Then what is this? Simple function. Okay, so if the health is 0, we want to update the monster to be gone. So we basically would do like over monster, and we just const nothing on s. If otherwise, we just return state. Okay. Now the monster should be able to... Oh. We get a crash? That's very unusual. For... I'm just gonna do this to restore. So what did you say? Something about monoids. No? No instance nor default method for class operation mempty. Yeah, okay. Okay, that is really interesting. Okay, so it allowed me to say that these doesn't have any members, or usually you have to define the instances. Okay, I guess I have to define mempty. Mempty is okay. So let's see. Now, how a monod works is basically, let's say you have an easy monod is the list, or an array, and mempty is just an empty array. And why it's empty is because, or it's also called I think it's what's called the identity of the monad, which means that if you use the operation, so there's one operation, and there is the set on which it operates on. And so basically the operation is basically like combine. And in a list, basically the combine is like append. You're taking two lists and merging them into one list. But there's a rule that you also need the identity, because if you take the identity and combine it with something else, the monad, it will become the same as the original monad. But if you so you have to think about, okay, so if you append an empty list on another list, it will be the same as the other list, right? So what about this integer? This integer I'm gonna say is like add. Let's say the operation is add. So what is empty if you add? So it's gonna be that if you add something to another number, it's gonna be the other number. So what is that? That is 0, right? But if you have multiply as the operation, if you multiply by 0, it's always going to be 0. So that's not really the identity. It's more like the anti-identity almost. So the identity for multiply is actually 1. Because if you multiply by 1, it's always going to be the other thing. So we have to make a decision then on integers, whether it's 0 or 1. But I'm just going to choose 0. And then I'm going to see what else it's complaining about that we are missing. Nothing. Okay, cool. So now the troll is dead. Yes! Alright. We have successfully managed to defeat the beast that is implementing a shoot 'em up in Haskell. Sort of. Is this to know what should be the health of there is no monster? Oh, that is correct. I mean, yeah, we saw that. What is the result up here? It's 0. So it's showing the empty here. It's showing the empty. Yeah. That makes sense. Good catch. I didn't think about that. It's just interesting to me that it allowed me to not put any implementations in these instances. Like that to me that would be like a compiler error, but apparently not. Yeah, okay, so basically over here it's like, okay, well, if we have a monad, we can, if there's nothing on this, we could use mempty, I guess. It's what's it's trying to tell me here, which I guess it's okay. Like, I would like to something that is like I guess we could have like when I don't know. Anyway, it's just, I don't know. Haskell is like, it's really cool language, but it takes so much, like, I don't know, it just takes so much energy and thought process to get something working. But then when you get into the flow, there's just so much cool stuff you can do with it. But it's also, when you get stuck, sometimes you can really get stuck. But yeah, it's a so cool language. But yeah, at the same time, it's frustrating as well. But yeah, this was kind of cool. This little side project here. But yeah, I have to go now. So thank you very much for joining me here. And so I'll see if I don't know if I can stream tomorrow. We'll see. But yeah, thank you very much for watching here, and I'll see you later. Bye bye.